Thank you so much, everyone. Well, let us now begin Thematic Session 5, Environmental Protection and Natural Resource Management. I welcome our chairs, Dr. Aladin Danila, Professor P. Rajendra Prasad, Professor Nc Gupta, and Dr. Arvind Kumar. Well, moving the proceeding part done, I would like to tell you about Dr. Aladin, Institute of Basic Biological Problems, RAS IBVP, RAS, Department of Functional Ecology, Russia. He specializes in development of new methods and techniques for eco-biotechnology, remediation of soil, water, sewage, sludge on persistent organic pollutants, soil-plant atmosphere interaction, soil respiration, monitoring persistent organic pollutants of environment. Also, as we have Professor P. Rajendra Prasad with us, welcome, sir. Author, Cotton Geospatial Chair, Professor, Department of Geophysics, Andhra University. He's an expert in water quality, watershed hydrology, water balance, integrated water resources management, groundwater hydrochemistry, water quality, and surface water, also hydrophysics. Welcome, sir. And now may I move on to Professor Nc Gupta. Dr. Nc Gupta is former dean and professor with the University School of Environmental Management, USEM, and he is one of the founder member of USEM, Center of Disaster Management Studies in GGSIPU. He has more than 28 years of research experience, out of which 21 years of teaching experience, environmental management, natural resource management, chemical technology, disaster management. He has carried out several consistency assignments for NTPC, IPGCL, power plants, and Larsen and Toubro, to name few. He has published more than 100 research papers, international and national journal at the same time, and he's a member of various DST committees. Also, I would like to welcome you, sir. And last but not the least, Dr. Arvind Kumar, Scientist International Cooperation Division, DST, New Delhi. Welcome, sir. So here I request Dr. Aladin Danila to start sharing your slides and begin your presentation, please.
Good day, dear colleagues. Glad to see you on our first conclave. I just want to speak about, great challenges for our society. Let me begin. Yes. Mm, mm. Sorry, demonstration. Okay. Can you hear? Can you see my screen? Uh, so, Problems and prospects of joint research to solve major problems of SCO member states, environmental pollution, problems of biodiversity conservation, climate change, shortage of natural resources. President of Russian Federation made a decree about strategic planning of Russian Federation. So he talks about strategy of the scientific and technological development of Russian Federation. He talked about great challenges for society, state, and science to increase an increase of anthropogenic pressures on the environment, to scale the treatments, the reproduction of natural resources, and increase risks to life and health of citizens. So there is a number of priorities and prospects of scientific and technological development of Russian Federation. It's transition to advanced digital intelligent production technologies, robotic system, data processing, artificial intelligence, and others. Second is transition to environmentally friendly and resource-saving energy, increasing efficiency of production, deep processing of hydrocarbon raw materials, formation new sources, methods of transportation and storage of energy, transition to personalized medicine, high-tech healthcare, and other rational use of drugs, highly productive and environment-friendly agriculture and aquaculture, development of implementation of systems for rational use of chemical and biological protection of agricultural plants and animals, counteraction against technogenic, biogenic, socio-cultural threats, terrorism, and ideological extremism. And it's very important for Russian Federation, connectivity of territory through creation of intelligent transport, telecommunication systems, and others. So problems demanded by requests of our states, five big problems: environmental pollution, changing of climate, conservation of biological diversity, scarcity of natural resources, and biosafety. For example, major environmental problem arisen with use of natural water resources. Russian border passes through big big territories where more than 1,000 transboundary water bodies, including 70 basins of large and medium rivers. In international water basins, there are many technological problems of water allocation, water use, harmonization of water management, fixation of pollution, which develop into political ones due to need to determine a contribution of each of body countries to water pollution, the sources of which are located in different countries and their responsibility. Solutionless issues not possible without scientific community, of course. Soil degradation, mostly in Asian countries, according of lossless research, annual losses allocated with land degradation and unsustainable land use in Central Asia amounted about $6 billion. Total annual economic losses in Kazakhstan may amount to 93 billion tenge. In Kazakhstan, up to 70% of land suitable for agriculture is subject of degradation. Degradation continues and associated with such human activities as overgrazing, poor irrigation, deforestation, and irrational use of water. So, intensity of climatic change is growing. And you can see on the picture the growth of annual temperatures last 40 years in territory of Russia is 0.45 degrees over 10 years, especially in the European part of Russia. It's significantly faster than global one, 1.17 degrees over 10 years. You can see changes in the risk of heavy droughts in European part of Russia in the period of May, June, and mostly August. It's more dangerous month of the year. Forecast of changes of productivity, you can see in 20 years, it's not so good. Ongoing climate change would have devastating consequence for countries of the Asian region, which is in turn can seriously affect their future growth, reverse current development, gains, worsen the quality of life of their population, says new report from Asian Development Bank and Potsdam Institute of Study of Climate Change. So, biosecurity. The rise of temperatures increase the risk of developing infectious disease, since causative agents of many infections are activated precisely in warm weather conditions. So, for example, exotic tick-borne borreliosis and tick-borne encephalitis, people can suffer from these diseases. In Kazakhstan, number of attacks on the people growing. And for example, 15 years ago, exotic ticks were not observed in the territory of Almaty. Locusts do not recognize borders, you know, due by ecological characteristics, locust species become even more dangerous in the context of weather events associated with climate change. In particular, locust situation has worsened due to frequent droughts in the early 21st century. For example, our work is developing of and testing technology of processing sludge from urban wastewater treatment plants and technogenic soils into organic fertilizer. I think it's quite needed for our society too. So thank you for your attention. Uh, mm, any questions?
Yeah, I think if I'm allowed, Dr. Gupta ji, can I just?
Yeah.
Yeah, this is Rajendra Prasad.
Yes, good afternoon. Good afternoon, everybody.
Good afternoon. Good afternoon. Glad to see you.
I think see, one of the issues that I was just looking at is you have covered the entire environment and then the other resources sector. As far as the water is concerned, you see how keenly the water distribution systems concentrate on water quality, because or the entire water quality issues are being taken care at the source itself before the distribution, and the how are the geogenic sources are being treated. Do you normally in the country you just handle them right at the source level and then transmit it through different systems, or would you do it there? Then another concept which I was just looking at is, because your environmental aspects were so good, because of the treatment systems which you get everywhere, like not only water, any other treatment would result in the production of a highly concentrated contaminant. So its disposal really becomes a difficult mark. Earlier we were talking about routine waste disposal, but now after the treatment, the waste that is generated, be it solid or liquid, it's likely to have a real big impact. So what are the measures that your country has taken in this particular aspect would be really be useful for the rest of the SCO nations? That's what I feel. Okay.
Okay. Thank you.
All right, doctors. So do we have any other questions? Or we can proceed further.
So we should proceed.
Yeah.
All right. So next, I would like to welcome Professor Nc Gupta, IPU New Delhi, India, to kindly start the presentation. Over to you, sir. Professor Nc Gupta. So may I request you to please unmute yourself?
Yes, I am sharing.
Yes, sir.
I am sharing.
So
A very good
please
afternoon.
Keep it as
Am I
full
audible?
screen. You are audible, but I would like to request you to keep it as a full screen so that it will be more visible. The slides, you need to keep it full.
Okay, I am trying.
You have a bar at the volume. Yeah. After that, you can move that bar. It will become.
Yes, it's perfect. Please go ahead.
Okay. Thank you very much for inviting me. I thank you. Good afternoon, everybody. Dear Dr. Aladdin Donila from the Institute of Basic Biological Problems, Russian Academy of Sciences, and Professor Rajendra Prasad from India, and Dr. Arvind Kumar from Department of Science and Technology. A very good afternoon to all of you. And dear participants, the presentation of my topic is environment, status, challenges, and the way forward. You know, the environmental challenges, until we experience a prolonged power cut, most of us take the availability of electricity for granted and do not think about how dependent we are on energy. Most of the world's energy comes from the fossil fuels, which include petroleum, oil, coal, and natural gas. And the next most important common source of energy is hydropower. It constitutes around 6.2% overall energy share of the world. While it is considered clean and renewable, but it is also having environmental impacts, and it also affects natural habitats. And if you see here, the petroleum products, that's oil, coal, and natural gas, they constitute around 86% of total energy share from the fossil fuels. And still, you see the clean renewable energy like solar, wind, geothermal, and biofuels are around 2% only in world's energy share. And there is a depletion of the natural capital. You know, freshwater resources are being consumed by agriculture, by industry, and for domestic use. But more than 1 billion people lack access to the clean water, and 1.4 billion people on this globe, they lack access to the electricity, 1.4 billion. And the demand for new land, fuel, and raw materials is resulting in deforestation, the conversion of forest land to non-forest land, and the degradation of semi-arid land, resulting in the expansion of desert land that is unusable for agriculture. Friends, the climate change kills an estimated 30,000 people per year on the globe, and mostly in the developing world. And this is a report from the Humanitarian Forum 2009. The majority of these deaths are attributed to crop failure, leading to malnutrition and hydrometeorological disasters like flood, cyclones, and droughts. We have already seen, the floods, cyclones in India. The frequency of occurring of cyclones is increased in the coastal area of India, as we are very vulnerable for the cyclones, particularly India, because we are having a 7,000 kilometers of coastal line in India. The effects of climate change include the melting ice and rising sea levels, flooding and the spread of disease, threat of species extinction, and extreme weather conditions, and forest fire. We have already seen the increase in forest fires in Australia, in California, in Amazon basin, and its impact on the global flora and fauna. Friends, about 30% of the world's surface is land, which provides soil to grow food. Increasingly, humans are polluting the land with nuclear waste, solid waste, and pesticide. You see the city like Delhi in India. 8,000 tons of metric tons of solid waste is generated every day in Delhi, and it's a major problem to handle the waste. In 2011, 1,287 hazardous waste sites were there, known as Superfund sites. Those were on the national priority list in United States of America. The chemicals, carcinogens, and health problems are also a great concern. About 3 million tons of toxic chemicals are released into the environment each year. And chemicals in the environment enter our bodies via the food and water we consume, the air we breathe, and the substances with which we come in contact. And the 12th report on carcinogens lists 240 chemical substances that are known to be human carcinogens or regionally anticipated to be human carcinogens. Friends, you can see this mother puts sunscreen on her child to protect against sunburn. But sunscreen, like other personal care products, may contain toxic chemicals. You see, the many personal healthcare products, they contain chemicals with known or suspected adverse health effects. There are threats to the biodiversity. Ecosystems are the complex and dynamic relationships between forms of life and the environment they inhabit. Over the past 50 years, humans have altered ecosystems more rapidly and extensively than in any other comparable period of time in the history. Friends, there are an estimated 8.7 million species of life on Earth. And some scientists believe the number is much more, and only 1.3 million of which have been named and catalogued by IUCN. And this enormous diversity of life provides food, it provides medicine, it provides fibers, it provides fuel for the poor, purifies air and fresh water. This pollinates crops and vegetation and makes soil fertile. You see the chemicals, carcinogens and health problems, mammals, you see the threatened species worldwide listed in 2011 by IUCN. Mammals 1,134, birds 1,240, amphibians around 2,000, reptiles 664, and like this, like plant species 9,098, and other fungi, lichens and brown algae 9. In total, around more than 16,000 species are under threat. Some are endangered, and some are endangered, and some are vulnerable. Friends, the air pollution is also a major problem particularly in developing countries and in cities. We are also facing a problem with air pollution in Delhi city. Transportation, fuel combustion, industrial processes, burning coal and processing minerals from mining and solid waste disposal have contributed to the growing levels of air pollutants, including CO2, carbon monoxide, sulfur dioxide, arsenic, oxides of nitrogen, mercury, dioxins and lead. All are harmful for humans and animals, and air pollution, which is linked to heart disease, lung cancer, emphysema, chronic bronchitis, and asthma, kills around 3 million people a year. And of this, 3 million, majority are in Asia, in China and India. Significant population in the world lives in the area where they are exposed to unhealthy levels of air pollution. You see this, there are evidence that air pollution is a major risk to health, and particularly PM1 and PM2.5, they pose a major risk on the humans. You see the lungs, the main entry point of pollutants, and target organs like alveoli and millions alveoli there are 300 million pulmonary alveoli in the human lungs. So the area, if you see the area of the human lungs is around 200 meters square, it's like a tennis court. And adult human breathes around 15,000 liters of air every day. So you can see if the concentrations are higher in ambient air, then if the lungs have to process 15,000 liters of air or more every day in 24 hours, then how much pollutants you are breathing with polluted air. You see the lungs are exposed to outdoor and indoor air pollution. Then air pollution, there was some reports by HEI, Health Effect Institute, that air pollution has shortened lifespan in South Asia by 2.5 years. And exposure to indoor-outdoor air pollution contributed to over several millions in India in 2017. And each year, more people globally die from air pollution-related diseases than from road traffic injuries, malaria, and other. Overall, long-term exposure to outdoor and indoor air pollution contributed to nearly 5 million deaths due to stroke, diabetes, heart attack, lung cancer, and chronic lungs disease in 2017 as reported by Health Effect Institute, HEI. Out of 5 million, 3 million deaths were directly attributed to PM2.5, and half of which were from India and China altogether. But India is taking a lead to reduce the air pollution, particularly air pollution, indoor air pollution from kitchen, like by Ujjwala Yojana, promoted by the Prime Minister of India, by the government of India, and household LPG connections are given to poor. And the accelerated Bharat Stage 6 norms for clean air program have the potential as a part of sustained commitment of the government of India to air quality and resilient health in rural and urban areas. And report from HEI highlights 3.6 billion people were exposed to household air pollution in 2017. If you see the world over 2.8 billion people, they don't have access to clean fuel in their kitchen. 2.8 billion people, they use world over biomass as a fuel in their kitchen. I will skip this slide. The diesel is a carcinogen. Diesel exhaust cause cancer as per the reports of WHO. You see the indoor pollution and outdoor pollution. You see indoor and outdoor in some Himalayan states, outdoor and indoor both are polluted if you compare. And in home, household energy, fuels and technology used for cooking, heating and lighting there is new air quality guidelines. They can reduce the air pollution from the kitchen by using the efficient cooking stoves following emission rates provided by WHO, and we should discourage the use of kerosene stoves in rural areas, and do not use the coal in kitchen, and use clean fuels like LPG, biogas, and ethanol to reduce the indoor air pollution and to upgrade the health in rural areas. I will skip this slide. And you see the commitment of the government by providing the efficient cooking stoves in rural areas, LPG connections, then they can reduce, they are already reducing the air pollution from the kitchen. Now, integration of housing services, schools, and recreation can reduce travel, and it can promote the active travel also. Land use planning is one of the most effective measures to promote physical activity and reduce pollution. Schools within walking distance to homes can reduce CO2 emissions by 12%, shrinking business home distance by 20%, as a study in Santiago in Chile. And the integration of land use and transport will define the shape of an urban growth as energy obese or energy trim. How it will define basically the quality health of the people, they are trim or they are energy obese. You see the geometry of housing densities, transport energy use, the per capita transport energy use per capita, like in US cities, in Atlanta, Houston, and Denver, they're highest. But in cities of Asia, if you see from the energy per capita energy consumption in megajoule, is less. If you compare in Asian countries like Chennai, Jakarta, and Manila, the per capita consumption of energy is less as you compare the cities in United States or in Western countries or Europe. Sustainable transport health benefits of the sustainable transport health benefits. They can increase the physical activity, and they can reduce the traffic incident, and eases movement of elderly, children, disabled persons. So we should promote for social cohesion also in local communities. Sustainable development goals. 3, health. We have to ensure the healthy lives and promote well-being of all at all ages. And by 2030, substantially we have to reduce the number of deaths and illnesses from hazardous chemicals and air and water pollution and soil pollution from contamination. And proposed indicators are mortality rates attributed to household and ambient air pollution. And you see Sustainable Development Goal 7, for energy for all, to ensure access to affordable, reliable, sustainable, and modern energy for all. By 2030, and we have to ensure the universal access to affordable, reliable, and modern energy services with efficient use. And the other indicators are percentage of population with primary reliance on clean fuels and technologies at the household level. And to meet the sustainable goals, 11, sustainable cities. We have to make cities and human settlements inclusive, safe, resilient, and sustainable. By 2030, we have to reduce the adverse per capita environmental impacts of cities, including by paying special attention to air quality, municipal solid waste management. And this can be done by indicator annual mean levels of fine particulate matter. We have to reduce, because PM 2.5 and PM 1, they are responsible for, for the poor health, particularly for poor lands in developing countries, particularly. And this can communicating the synergy, physical activity can reduce the obesity, and they can also reduce the traffic injuries, they can increase the social capital, and can reduce the cardiovascular diseases and depression among youths, and at the same time the air pollution. And resilient health from air pollution reduction, there are less injuries, more physical activity, and less noise. And air pollution can reduce by controlling this can be reduced PM 2.5 and PM 1, and climate change, short-lived climate pollutants can also be reduced, like black carbon aerosols, which are responsible for the the large share of in climate change. At the same time, can also reduce the transport energy and land use. Policies, efficient policies can reduce the climate change. For climate change, they can reduce the CO2, and they can control the the climate change gases, which are responsible for the climate change. New resilient urban health climate approach can be to mitigate the air pollution, to mitigate climate pollutants like short-lived climate pollutants and CO2, to maximize the health benefits, and how we can equip and engage city actors in health planning and development by health knowledge interventions with greatest health benefits, tools for health assessment, to strengthen the institutional and technical capability and capacity, and framework for collaboration, monitoring and evaluation, and communication awareness, spreading the communication and awareness among people. What are the way forward to respond for the climate change, for the environmental challenges like green energy? Increasing the use of green energy, renewable and non-polluting, can help alleviate environmental problems associated with fossil fuels. Green energy sources include solar power, wind power, and hydrogen. And biofuels derived from agriculture crops like ethanol and biodiesel can also supplement as a green energy sources, green energy fuel. Wind power, wind energy is harnessed by turbines such as those pictured in this photo. Like if you see India, we are one of the leading producer of wind power, more than 15,000 megawatt of share of wind power in total energy use in total commercial energy use in India. And there are strategies for actions to respond for climate, to respond for environmental challenges, modification in consumer behavior. If you see this picture, the green building, this basically is developed in the university, in college university campus in the state of Ohio in USA, and the most environmental friendly building in world. And the building basically was resulted from the vision of professor of environmental studies at this college. Now there are studies for action to respond for the environmental challenges. We have to go for international cooperation and international assistance, mutual international cooperation, sustainable economic development, and at the same time, the role of institutions, of universities and technical institutions of higher learning, and to understand the environmental problems thoroughly. Friends, this is a quote of Mahatma Gandhi: a technological society has two choices. The first is, it can wait until catastrophic failures expose systemic deficiencies, distortion, and self-deceptions. Second, a culture can provide social checks and balances to correct for systemic distortion prior to catastrophic failures. Friends, speed is irrelevant. Development is irrelevant if we are moving in the wrong direction without taking care of the environmental protection at our end. Thank you very much. With all this, I conclude my talk here. Thank you very much.
All right, doctors. So do we have any Q&A session happening around the corner? Any questions?
I just want to say, Professor Gupta, that problems what we are talking about crossing in 19%, I think.
Pardon?
Problems, what we're talking about is crossing on 19%. We're talking about same problems.
Okay.
Yeah, Aladdin, you're right. I think see the problems in almost in all our spaces are rather identical, not even similar. So they are, but I think a concerted effort in this direction really should help us to come out of this much sooner than what's going on today.
All right, doctors. So I would like to thank sir for such a nice presentation. And I request Gupta sir to kindly stay back with us for a networking session. But meanwhile, let's take a lunch break for 45 minutes. And then we're going to be back with Young Scientist presentation, starting with Dr. Yin Tang, Institute of Geographic Sciences and Natural Resources Research, China.
Palveji, Muslim Bek has sent a request that he could not present because of technical glitches. So just see if you can accommodate him.
All right, doctor. So after lunch, maybe we can prep it up with that. But for now, we are taking a break of 45 minutes. So we're going to be back sharp at 2:15 Indian Standard Time. And let's proceed the presentation part. Thank you so much, everyone. We are taking a 45 minutes break till then. Thank you. All right, everybody. So yes, once again, welcome back to the Young Scientist presentations in thematic area, environmental protection and natural resource management. I would like to request Professor Nc Gupta and Dr. Arvind Kumar to kindly continue to chair the session, please. And now let's begin with the first Young Scientist presentation by Dr. Yin Tang. Over to you, Yin Tang. Yin Tang, I would like to request you kindly unmute yourself. You need to unmute yourself.
Yeah, now, okay.
Yes,
Can you
yes,
hear
perfect.
me now?
Yeah.
Okay, good. Next I will share my screen. So does it work? Does it work? Can everybody see my slides?
Yes, yes. Is it full screen, sir? All right, perfect. You can go ahead.
Oh, okay, thank you. Hello, everyone. And this is Ying Tang. And I'm from China. Now I work at the Institute of Geographic Sciences and Natural Resources Research at Chinese Academy of Sciences. And today my topic is about the reconstructing annual groundwater storage changes by integrating the remote sensing data and water balance model. As we know, the groundwater is very important resources in nature, and it can recharge rivers and irrigating the crops. But unfortunately, recently, several studies reported that the groundwater depletion increased very rapidly. And it means we should emphasize the monitoring of it. However, it's very costly, especially for the large basins. So we need to propose the innovative methods to simulate the groundwater storage change. So in this project, we try to develop a method by integrating the remote sensing data and the simple water balance model to reconstruct it. And the remote sensing data is from the gray satellites, which are twin satellites, and it can measure the gravity of the Earth. Then we can derive the total water storage change by this satellites data. And if we have those things, then we can get the groundwater storage change based on this water balance equation. And the simple model we choose is the Boudical model, which is proposed by a Russian meteorologist. And the original one is describe the long-term climate controls on the hydrological processes. Afterwards, scientists developed the one-parameter Boudical types model, kind of those one. And the things we do is we introduce the effective rainfall, and we replace this with the precipitation in the original model, then the total water storage change can be integrated. Then we get the new model. And in this model, it has two parameters. And if we have the inputs of precipitation, evaporation, and potential evapotranspiration, then we can get, and also the Gray's observed total water storage change, then we can estimate the parameters. After that, if we institute back to this model, then we can get the simulated total water storage change and combine this water balance equation, then we can derive the groundwater storage change. And I think the idea is not difficult, and we apply this innovative method to a irrigation region, then we can see the performance in the right-hand side figures. And the upper one shows the simulated total water storage change and the observed one, and the black curves is the observed one, and the red curves are the simulated one. We can see the agree well, and the lower figures shows the derived groundwater storage changes. Besides this work, we still do some surface water processes on the climate change. We try to develop models to understand the roles of vegetation, soil, and topography in the hydrological processes. And we also focus on the impacts of climate change and human activities on stream flow changes. And we also care about the stream flow sensitivity to climate change. Previously, people also just focus on the stream flow sensitivity to the long-term climate change, but recently we found we proposed a method to quantify the stream flow sensitivity to the interannual climatic variability, and we provided the maps for the interannual climate elasticity. Besides this, we also focus on the natural hazard. We do the flood forecasting and water resources management. We also do some field work to understand the evapotranspiration processes. So if you are interested in those work, you can find the details in this publication list. And we warmly welcome to the collaboration for addressing the water scarcity around the world, especially under the climate change. And our institute is a multidisciplinary research institute. And the lab I worked for now is mainly focused on the water cycle and related land surface processes. And we're focusing on the surface water and groundwater processes, the soil erosion, and the natural hazard controls, and so on. And our institute also offers the PhD and master programs and postdoc positions. So if you are interested, you can find the information at this website. And I think that's all for today. And thank you so much for your attention. Yeah, I think that's all. So,
Thank you so much. Well, I would like to request Professor Nc Gupta to please may continue with the Q&A with Arvind sir. Professor Gupta, you need to unmute yourself. Yeah.
Thank you very much for a nice presentation. With this technique, can we find out the moisture contained in soil in agricultural areas?
Oh, okay. For this type of data, we get the simulations from land surface model. So the soil water storage change is from the simulation one. It's not the observed. Thank you for this question.
Okay.
Yeah.
Can I ask?
Any other questions?
Yes, I have one question, Ms. Tang. What is the accuracy of your prediction? Means based on your simulation versus observed, what was the, you can say, the range and also the prediction error?
So you mean the uncertainty or
Uncertainty.
uncertainty? Yeah, we choose like a different source of precipitation and the simulated soil water storage change, and then we estimate the uncertainties. And maybe if you see that figure, the uncertainty is not very high. Yeah.
No, but do you have any calculation of uncertainty, like 5%, 10%?
We have this calculation, but the numbers I can't remember. Sorry. So the details you can find in the publication, and this paper has been published in 2007 in Journal of Hydrology, and you can find the details in that. But the accurate numbers I can't remember now. Sorry about that.
So you have used the methodology of GRACE, remote sensing. So GRACE is generally used for larger scale, continental scale or the regional scale, but you had made
True.
made it at the local scale. So what are the challenges and what are the, you can say, customization you did while making the result or your simulation?
Oh, thank you for this question. That's very good. That's a good question. Yeah, as you said, the GRACE is only applicable for the large regions. So our case study is also for a large scale. Like we apply this model in Punjab in Pakistan, and the area of this region is like, I remember it's more than 2,100 square kilometers. Yeah, so for the small regions, the GRACE satellite and the data is not applicable. Yeah, that's the limit of this method.
And at what temporal scale as well as the spatial scale you have taken the data for your study?
Yeah, the temporal scale is the annual. We only can reconstruct the annual groundwater storage change. Like for the finer scale, this method also can't applicable. Yeah.
And how many years of data used for?
We like the 10th years, like maybe our time series is from like 1985 to 2015, maybe 30 years about. Yeah.
Okay, 30 years sufficient for any statistical analysis. So data range is okay. Anyway, this is my short, you can say, comment or you can say questions. Any other person can also ask. In audience can ask the question, please.
Yeah, thank you. Thank you for these good questions. Yeah.
Aladdin.
Mr. Aladdin, I would like to request you to unmute yourself.
I just want to ask about water basins. You know, river basin. You can count large rivers and river basins. You know. No, it will work with only big rivers.
Yes,
The
true,
big,
true.
the
'Cause
big water basins, yes.
yes, yes, true.
Wonderful.
Yes. Okay, thank you. Yes, thank you for this.
All right, doctor. So as Dr. Aladdin has joined us, I would like to request you, sir, to kindly continue the chair session.
Oh, okay. So next one is Kun Won. Yes.
Yeah. Can you hear me?
Yeah,
Okay.
yeah.
Okay, I will share my screen. Thank you. Okay. Okay. It's a great pleasure for me to attend this conference. I come from Xiamen University in China. My topic today is occurrence of ALGs in drinking water biofilter and their removal by boiling. So we start from the bacterial antibiotic resistance. The number of medical cases associated with antibiotic-resistant bacteria is increasing worldwide, while antibiotic development has not kept up with this rise, leading to the worldwide problem of bacterial antibiotic resistance. It was predicted that the deaths caused by antibiotic resistance will reach to 10 million in 2050. BAR is encoded by antibiotic-resistant genes, which are present in both environmental bacteria and pathogens. In recent years, ARGs has been defined as emerging contaminants. BAR problem in drinking water is worth of attention. Recent years, many studies have detected ARB and ARGs in tap water, and sometimes even superbugs, which indicated that municipal drinking water has a serious risk of bacterial antibiotic resistance. So we focus our study in drinking water treatment in order to find the source and the cause of the bacterial antibiotic resistance. As shown here, this is a typical drinking water treatment process, which consists of pre-ozonation, flocculation, sedimentation, sand filtration, post-ozonation, and activated carbon filtration and disinfection. We compared the energy concentration and their relative abundance in effluent of each treatment process by literature review. We found biofilters such as biological sand filter, biological activated carbon filter, and disinfection play important roles causing BAR problem in drinking water treatment. So we start our experiment on BSE filtration at full-scale drinking water treatment plants. This figure shows the comparison between ALG contamination in BSE filter from our study with in other environments from published data. From this figure, we can easily find that the ALG detected in BSE filters were more diverse and more abundant than most polluted environments, such as polluted surface water, sediment, activated sludge, and so on. And we also detect the ALG throughout the backwash cycle of the filter. As we know, backwashing is to pumping water backwards through the filter media, which is the most important measure to operate filtration and to keep filter at a good performance. We found that the ALG richness remains stable throughout the backward cycle, indicating that most ALGs persist in BSE filters despite of the backwashing. So what is the driving force for ALG persistence in drinking water biofilters? As we know, antibiotic is often considered the most important driving factor, as antibiotic could cure the antibiotic-sensitive bacteria or inhibit their growth, which will create space for the growth of antibiotic-resistant bacteria. However, in drinking water treatment, the selective pressure, including antibiotics and heavy metals usually present at extremely low level or even not detectable. Given such low selective pressure, ARB screening is rarely possible. So there must be other factors to drive the ARG persistence in drinking water biofilter. So then we established a pilot scale drinking water biofilter system to find out the potential reasons. We found increasing trend of ARG abundance with increasing field depth in all filters. Such trend is highly correlated with the decreasing organic carbon concentration. As we know, when water flows through the filter, organic carbon will be continuously consumed by the filter biofilm. In addition, we also found significant positive correlation between the ARG abundance and the abundance of mobile genetic elements. So we think the oligotrophic environment and horizontal gene transfer are the main factors for ARG persistence in drinking water biofilters. We further designed experiment to let antibiotic-resistant bacteria compete with antibiotic-sensitive bacteria at different nutritional levels. And we found that the antibiotic-resistant bacteria showed higher fitness under lower nutritional levels. So as we know, drinking water is a typical oligotrophic environment. So such environment is conducive to the maintenance of ARG. During the drinking water treatment, as we know, the persistence of the residual chlorine and disinfection byproducts will also promote the maintenance of the antibiotic resistance. Considering to this factor, it is very difficult to control bacterial antibiotic resistance in the process of the water supply. So, in order to reduce the potential healthy risk, it is necessary to treat drinking water before drinking it. As we know, boiling water is a drinking tradition in East Asia, and we detect the ARG concentration in drinking water before and after boiling to see if the removal of ARG by boiling is effective. From this feature, we can see that the ARG abundance decreased significantly after water is boiled for about 3 minutes, and completely removed at 10 minutes. So that's all about my work. Our research team focuses on studies on drinking water treatment process and water treatment microbiology, advanced or oxidation technology for water treatment, environmental functional materials and their application in water treatment, and water quality assessment. We are interested in international operation. That's all about my presentation. Thank you.
Thank you very much. I just want to sharp that it's very needed to our society investigation, because my research found that in wastewater, wastewaters, it's between 20 years ago and now, there is thousands and hundreds times less Escherichia coli, because it's great pressures of antibiotics, much less the bacteria in wastewater. I think it's very needed. Your research is very now. Yes.
Yeah.
Other questions, please.
Thank you.
Is anybody have questions? So we must transit to next one, next presentation.
Yes, sir. I have one question. What will be the best supporting media for biofilm development having maximum efficiency in treating wastewater?
Pardon. So you mean what is media in the
Yeah.
filter?
Yeah.
In our research, we use activated carbon. This media is usually used in drinking water treatment because it's easy for bacteria to attach and grow to biofilm on it. So it is frequently used to remove organic carbon. You know, sometimes the source water is polluted by organic carbon. Yeah. So in wastewater treatment, we don't do research on wastewater treatment, but in our opinion, to remove organic carbon, you will use activated sludge, and I think it's a large biomass than the than biofilter in drinking water treatment. So
Okay. One more question, sir. How can we determine saturation point of a biofilter medium?
pardon, how
How can we
I didn't
determine saturation point?
determine what?
The biofilter medium saturation point.
Yeah. Why I choose BIC filter, right?
Yeah.
Do you mean this? Yeah. Cause we do this experiment in a full scale drinking water treatment. Since we do literature review, we found the effluent of bacteria BIC filter. The effluent of BIC filter contains a large amount of antibiotic-resistant bacteria and genes. So we think it's a hotspot for the drinking water treatment. Because after BIC filtration, then we use disinfection to kill bacteria. But most disinfection methods such as chlorination and UV treatment cannot remove these bacteria. So we focus our study on BIC filter.
Okay. Thank you, sir.
Okay.
Dr. Laden, I think we are done with the questions.
Yeah, we must go to the next presentation. Dr. Kofakota, yes?
Yes. Sir, it's audible. Myself, Dr. Anjanelu Kotakota.
Please, we will listen to you.
It's visible. It's visible. My PPT is visible.
No. Please show your screen demonstration.
It's okay now.
Yeah.
Yeah, thank you. Myself, Dr. Anjanelu Kotakota. I am working as a scientist in Agro Processing Technology Division, CSIR, National Institute for Interdisciplinary Science and Technology, Trivandrum, Kerala. Today, I am going to brief about biodegradable products from agro waste. Thank you, Shanghai Cooperation Organization and Department of Science and Technology, giving an opportunity to explore our research all over the world. Problem identification. Generally, today, sorry. Sir, sorry for disturbance. Yeah, problem identification mainly. The major issue is plastic. Due to plastic, so much health issues are coming all over the world, and mainly its effect for the animals and even effect for the human beings also. According to the literature, for European Bioplastic Information and Indian Environmental Pollution Control Board, the more than half billion plastics are used everywhere around the world, and 16 billion disposable plastic coffee cups are used each year in simply discarding the earth, and is causing so much shockings and creating a huge environmental pollution problem. And coming to the India, majorly in India is the agriculture processing country. It's depend upon the agricultural processing technique. Around 80% depend upon the agriculture processing. If you go for agriculture processing, major issue is that if you process during processing and harvesting time, there are so much rice stubbles and wheat stubbles will generate. That stubbles is simply the farmers burning, creating the environmental issue. For it causes harmful for the nation, harmful for the environment also. So for that solution, we start working on the biodegradable development of biodegradable products from agro waste. And our prestigious Prime Minister Narendra Modi, he says one word at the United Nations meeting in September 2009. I think the time has come for the world to say goodbye to single-use plastic. By using his motivation, we started working on that, and utilization of this waste an alternative to single-use plastics provide an immense opportunity to the entrepreneurs, especially new entrepreneurs, new young entrepreneurs who are interested to start their business in India and all over the world. Generally work done on future direction. We have already, when you going working on, we have selected several agro waste like rice, wheat, sugarcane, coconut, and pineapple, banana, and industrial waste. Majorly in our food industry is emerging in India like anything. So during the processing of like beverages and all, there is a huge amount of peels and fruits and vegetable fields are generating. For the using this all the kind of waste, we are started producing the biodegradable products. We have developed the technology, and we transferred this technology to a couple of industries like new entrepreneurial industries. And and when working on this, we got an idea, so we developed the vegetable leather also by using this paste like pineapple and banana stem, because these containing high fiber content. Because now major problem of leather production also shortage of raw material, like leather will produce from like milk latex and also animal source. In ethical issues will come. So preventing all the things, we started working on the vegetable leather. Next one is food packaging materials, because now if you see in everywhere, India is a mass population country. During the transportation like railways and airport, there are plenty of snacks. They simply discarding and creating the pollution problem. Actually, so many food industries approaching to our institute by seeing our biodegradable technology. Can you develop any food packaging material with from agro waste instead of using the paper and all? These are the biodegradable cutleries methods we opted, and we find out the solutions. Lastly, we have different methods we prepared, we developed, we optimized for the different kind of raw materials, wet process method and dry process method and cooking method. Because when wet process, little bit costly initial investment is required, because it's containing several unit operations like grinding, kneading, and it also requires some kind of binders for that. So some of the entrepreneurs told that, can you reduce this initial investment? Because in India is containing like farmers, there are plenty of like rice mill owners and wheat mills owners. They produce huge amount of bulk waste. So they can themselves, they start their business with less initial investment. For that, we have developed, instead of using any binder, without any binder, we have modifying the missions and we have modifying the technology we developed, and we developed the cutleries and biodegradable waste by dry method. Now after that, we go for the film packaging materials, especially food packaging materials and vegan leather. By using cooking method, we optimize that. We transferred this technology to couple of industry. These are the some of the cutleries we developed from our institute, and we have transferred to certain industries. These are the various waste biodegradable like pineapple leaf, food film, multigrains, and also wheat bran, rice bran. We have all the things work out. We done biodegradable tests and toxic studies for the animals. Next one, initial investment operation cost. Suppose some of the industries approaching and we are giving the operational cost, how it will be required, what is the equipments required, what is the cost of equipment. We are doing consultancy for the industry also, because we have 100 kg raw material producing around 2000 plates, 2400 plates for the with a weight of 50 grams. So there's different size, different shapes we are producing. The initial investment, like poor people, they can start their business. We having the plenty of raw material with one, that for 12 to 15 lakhs, they can start there with their business. This is one of the good opportunity for young entrepreneurs all over the world, is to start their business. Like we are working with various communities and collaborations because we are giving the training to the farmers. But India as a country has a mainly majorly depend on traditional based product, like traditional based packaging material, traditional based like go. Even I observed now European countries also preferring like areca palm leaf plates and also pineapple leaf plates and also in the especially bananas leaf. So, but major problem is the shortage of raw material due to they are approaching it, they revive the revival of industries. We are giving training to them by using agro waste like rice bran and wheat bran they can develop, and also we are modifying the methods like pineapple and banana leaf based products. And also we are one of the major achievement is that we established an industry in Cochin for automation based industry. The 500 kg per day processing is they are producing like huge amount of plates and they are launching in January. And our Kerala government also taken an initiation, and also Indian government also provided support for this, especially so like Coconut Development Board, DST giving funding for us doing the research. And we are doing this research and we are giving training to the farmers and also entrepreneurs like women entrepreneurs, especially who can start their business like association way. And even all over the India, we are giving trainings to them. Next, when working on it, this is our innovative idea approach, expected approach by food packaging. We are targeting for next year, especially in April, we are targeting, we want to develop the food packaging material from agro waste. We are working on this. We are developing, especially we are targeting for ice cream cups, wrappers, because there's a major issue everywhere, simply paper based and plastic based and PLA based they are using, and they are simply discarding, it's not degrading properly, and it's creating to the pollution to the ocean and water resources. Another one is vegan leather. By vegan leather, we are trying different methods. We are developing and we are giving for especially for the handbags, seat covers, carry bags, who are leather shortage people. So by using this, especially biological process, mechanical process, we are developing biological process. We optimize the strains and we are doing fermentation. We are developing, but the viability is very less in biological process. So mechanical process is very easy. So we process, but it's because entrepreneurs and industrial people, they need the immediate the results. So we are working for them the mechanical way, and we have developed the products and we are targeting for that for to work for the install the industries that thing. And this, and also working on this, some of the rural entrepreneurs, they need different kind of machineries regarding in this. Yeah, like that's why we developed like straw vending machine with the automation way, and also like steam compression unit, automatic meshing unit, fiber extraction unit, because so many farmers associations, they are extracting the fiber unhygienically, and also they're producing the cutleries and all things unhygienical. So for that we are preventing and we are giving advanced equipment with the low cost with our technology. This is the possible collaborations with our SEO nations, mainly who are interested to, we are interested working, we are easily to collaborate with them, especially in biodegradable bioplastic production from agro waste, and also mission and design and development from the agro processing and biodegradables. Our team, we have different expertise, especially myself an agro agriculture engineer and food process engineer, and also my team co-members like specialist in biodegradability, ecotoxic study persons are there, and also some materials science division like Shahu and they are the expert in polymer coating. We are, when whatever the developing your coating, EDA boost based 100% degradable coating solutions we are developing, and we are working on that. And also especially microbial specialists also there in our team. We are combination, we are working, we are developing this technology, we are giving to the nation. This about our institute. Majorly, our institute have pilot scale facility. Last 10 years, we are rolling and we are giving trainings, and we have the pilot scale facility for the biodegradable products. We have all the facility of like, because our institute has a multidisciplinary institute, and agro processing and chemical science, material science, environmental science and division, and also we have all the facilities of especially high costly testing for facility. Mainly, we have enable accreditation. For the dioxin and biodegradability. So many plastic industry from all over India, they are approaching, we are doing the test for that. And also we have collaboration with multinational companies like ITC, Tata Chemicals, and Kotakal, and especially all the companies we are collaborations. So we are working them, we are giving technology to them. If anyone interested to work, especially rural entrepreneurs, they are interested to start the business, we are giving consultation, we are giving technology to them. Thank you so much for giving opportunity.
Thank you. Thank you for your report.
Thank you, sir.
It's applied science.
Yes, sir.
Need to all countries, you know, and how think does it big market for your for
Yeah.
your production?
Yes, yes, sir. We are already in the marketing that a companies industries, they are marketing all over the world, especially Asian countries. They are Singapore and African countries. They are moving towards to that because our technology is very low cost and without any binders like PLA, that kind of not using. So there are so many people interested on that because now all the plastic is a PLA based and all. So it's not 100% degradable. It's mainly only under composite degrading. That's why people worrying about the PLA and the PBAT, PHCT. So without using that, we are developing that.
Oh, yeah. Thank you. Any other questions?
Yes. Can I ask a question, Mr. Dr. Kotha Kota?
Thank you, sir. Yes, sir.
Yeah. You know, in bioplastic production from agro waste.
Yes, sir.
Have you tested the time? How much time does it take to degrade?
29 days, sir.
49 days.
29 days.
Pardon?
29 days.
29 days.
Yeah.
And what type of coating you do on the this bioplastic? Because I think to make the surface smooth.
No.
What are the chemicals you use for will be used for coating of this bioplastic?
Especially in a rice bran and wheat bran, like cereal kind, we are not using any coatings, sir, because due to steam compression, because it's containing itself as a binder. One of the good nature for the wheat and rice, it's containing like gluten. It's act as a binder, whereas it act as a binder. No need of any coating. We will based on the steam compression by using the caramelization. It form a good outside itself. If you go for the pineapple leaves and banana fiber kind of thing, we are coating like edible oil based, low cost oil based coating solutions. We are preferring like palm oil. And we have developed the solutions and we are coating on further, especially tea and coffee glass cups, preparing the and packaging materials. Now we started now initial stage for wrappers and all initial stage. We are optimizing coating solutions for only pineapple and banana stem. Remaining other thing, no need of any coating.
And for this vegan leather, what is the tensile strength? Because when you make a shoe, from the vegan leather,
yeah. It's like stitching bad. We like sericulture stitching things. Generally like cloth shape, not that much strength, but we use like a cloth covering coating covers. We can't use like high strength kind thing, tensile and flexile stress. We can use like coating cover sheet, like sofa cover sheet instead of using, because in the majorly it's coming from leather, that thing. So we're reducing the shortage of that raw material. We developed this.
I think hand wax and other items can be used for this bag.
Yes. That is one of the target. Yeah. We can't use high strengthile place where the leather wherever applicable. We can use certain places to replace it.
And what are the chemicals are used to make this leather, vegan leather, shiny in nature?
No, sir. We are not using mainly coconut water is the base material we are taking, and fiber and actually pineapple fiber from coconut, and another one is that normal fiber like banana stem fiber, and we are doing it in the coconut water. We are using only biochemical, the biological process like fermentation. We are using the optimize the strains for especially Stobacter geylanicum and all. But we are not utilizing the in mechanical process by using the degumming and the strength of microwave, the microfibers we are extracting, that fibers we are going to stitching as a naturally we will stitch now woven meshing and all things, the clothing in Indian textile, that way we are producing.
Okay.
So if no questions anymore, next speech is from Poya Devi. Does he hear?
Here?
Please, Devi.
Yeah.
Materials engineering for water pollutants. Yes, Dr. Poya. Please.
Okay, I'll be sharing my screen.
Yeah.
I hope my screen is visible.
Yeah, we can see.
Okay. So first of all, I would like to thank SEO for this very good opportunity to give a platform to kind of the work we are doing, and an opportunity to build networking with the SEO countries to come up with kind of products and solution which could be benefit to all. So I am going to talk about the materials engineering for water quality monitoring lab to land. I'm a senior scientist at Central Scientific Instruments Organization, which is one of the CSI laboratory in Chandigarh. So what we work towards, we have two major aims to address the sustainable development goals. SDG 6, which is towards clean water and sanitation, and SDG 7, that is towards affordable and clean energy. And so we, as a group, we work on designing various kind of materials and translate those materials into devices to come up with a solution for water pollutant monitoring, where we are we are utilizing different kind of transduction platform like fluorometric, surface enhanced Raman scattering, fluorescence to come up with a solution for organic and inorganic pollutant detection, and as well as it's not only the detection part, we are working towards devices and solution for degradation of various water pollutants. The third area which we are exploring, we are working towards SDG 7 is hydrogen generation technologies, where as a material engineer, we have focused on developing efficient and stable photoelectrodes for hydrogen production from water so as to we can scale up. So just to give, and today is my discussion, I'm going to just present the one part of the work which we are doing is towards water pollutant monitoring, and the motivation behind water pollutant monitoring, as you know, like with the global economical development and lot of urbanization and industrialization, we have seen as a result huge amount of the wastewater has made their ways into the water bodies, whether it is surface water or the groundwater, and continuous consumption of these water lead to several health effects. Specifically, say if we see in the Indian context itself, several parts of the country, several states, they are affected with high level of arsenic or fluoride or heavy metals, bacteria or nitrate, and that also lead to a lot of burden onto the health system of any country. Therefore, it is important that we monitor our water resources, and these sensors has a big role to play. And these sensors also enable to check on the major source which are responsible for creating the pollution of these water resources. Globally, if we see that environmental monitoring and sensing market, the water sensor market has a big share of 32.44%. Most of these instruments, they are laboratory based equipment, like most of us might have used it, like ICP-MS, ion chromatograph system, and we need a skilled person to work on this system. And another thing that these systems, we can have only periodic sampling and testing of the water sources to understand the behavior, how the contamination is moving, what are the responsible sources. And so using those instruments in field is not possible. The other alternate is the affordable water testing kits. These affordable water testing kits, they give an advantage of primary screening of water resources for microbial, for organic and inorganic pollutant before going for lab-based testing. And they also, another benefit with these field usable kits is they also create awareness amongst the user, and they can connect themselves when they're using that water for any consumption, for irrigation or for routine application. And third advantage is that these kinds of solution could be integrated with the water treatment solution, or maybe water deployment which are there at different places. Maybe it is a railway station, or maybe in remote areas, or maybe a highly affected area where the treatment solution or water extraction solution are deployed. They can be easily integrated with this solution to understand the kind of the quality of the water which is coming out of this system, and they are user friendly. So in this direction, our group has started working to design the materials and come up with a friendly solution, the material which are environment friendly, and to design new chemical ligands so that we can make this sensor platform highly selective towards the kind of pollutant we are targeting. And as since we being an instrumentation organization, we work on the translation of our fundamental science into the product. So we have worked on the developing portable devices which can read the response of this sensor platform into the field, and also integrate various IoT feature into these devices to make it as a smart devices, so that the data can be transferred to the user or maybe the agency who's looking after the water quality parameters. So we have worked upon various kind of water quality sensors. Here I'll be showing you a brief overview of different platforms which we have developed for inorganic water pollutants. So just to give an idea, I'm not going to discuss more into technicality. We developed a carbon-based platform which is bioluminescent and environment friendly. The plus point of this platform is that it has high switch surface functionality that can be modified to design the sensor which we want to develop. And with our expertise in the area of chemistry, we designed certain ligands, and these ligands were designed in such a way that their position, their structure, or the heteroatoms are arranged in such a way they can bind to a specific ligand. And we mobilized those ligands onto the sensor platform, which was a carbon-based platform. And this platform we have, excuse me. So these platform we have developed, and we transferred this platform. We studied this platform under lab environment. First of all, we studied them for different concentration. Here as a case study, I'm showing how we have studied this platform for the selenium. And you can see that this platform could detect the selenium in the concentration range of 0.1 ppb to 1000 ppb. And like selenium is one of the model shown here. Selenium, even though it is a micronutrient, it has been recognized as an emerging water pollutant in different parts of several countries. China is also one of them who is affected with high level of the selenium. So what we realized that there is no kind of a field kit or field devices available which can screen the selenium into water resources or the soil. So we studied this platform. We optimized all the basic analytical parameters which are required to use this platform under the field application. And then we also came up with the pocket size fluorimeter, which is a very small device which can be used in field. And it not only gives an idea whether the selenium is present in water, it also gives an idea how much is the level of the contaminant which is present into the water. The plus point of these kind of platform is that this is a very portable, affordable, and it is a modular product. Like we can have multiple parameter added into the small product, so it can be used as a initial screening source, which could be placed into city level or MC level for initial screening of the water resources. So likewise, we other than fluorescence, we develop a novel material platform. Being a material engineer, we may specifically focus onto the material part. Like for the arsenic, the kind of solution which are being used, they are based on arsine chemistry, which are very toxic to handle. They generate a lot of toxic byproducts because mercury is used in those kind of kits which are available. So we developed a user-friendly material, which is based on direct detection of arsenic based on color change. And here you can see that it can in one go detect the level of arsenic by a mere change in color. And we studied it with a concentration range of 1 ppm to 50 ppm, and going further to WHO limit, and in the process to optimize it. And also not only in a reagent kit form, to bring more user friendliness, we are working towards developing the paper strip kind of platform, so that our dip test could give an initial idea the level of the various inorganic pollutant into the water resources. With the colorimetric platform, such platform, the major issue comes is the interpretation of the color, which is a very subjective issue. So to address this issue, the color interpretation may be, say, color may be pink for some person, maybe red, light pink for another person, or maybe dark pink for other person, which may lead to unclear information about the level of the pollutant. So to overcome that subjectivity issue, we develop a portable colorimeter, or you can say an imaging device, which on the basis of the image analyze the level of water pollutant And we integrated this device with a mobile app, which we have named as HMI Sense, Heavy Metal Ion Sense, which relate the color with the concentration of the water pollutant or the water which we are testing. And we have extended this device and the platform even for the residual chlorine monitoring, because the chlorination is the major method which is used for the treatment of the water in rural and urban area. And over chlorination and under chlorination may lead to several health effects. So current practices which is used for the chlorine detection are based on DPT chemistry. Again, the color is very subjective issue here. Then so we extended our developed platform to not only monitor the heavy metals, also for the screening of the treated water for the level of the chlorine which is present in water. So this is all about kind of the sensor devices. A brief idea I gave for the sensor devices. Besides that, we are working towards surface enhanced Raman scattering based platform for detection of the organic pollutant to the trace level, and that I'm not presenting here. The second innovative idea or domain which we are working is towards the hydrogen fuel. As we all are aware that there is a deficit in demand and supply of conventional fuel, and we are looking for alternative solution which should be environment friendly, which should be sustainable. So hydrogen energy is a promising fuel over there because of its high energy density per unit mass, its high combustion energy, and the best part of using hydrogen energy is on combustion, it releases water vapors into the environment. There are various methods by which hydrogen could be produced. Most of the current method globally, they relies upon the fossil fuels again, and some progress has been done on the biomass-based method. Electrolysis or photoelectrolysis is one of the promising renewable energy technology for generation of hydrogen energy. But the major challenge in these kind of approach is the design of the electrodes, which are whether it is an anode or a cathode. When we are talking about a PEC system or the electrocatalytic system, these electrode has to be stable, scalable, and they should be able to produce the hydrogen in enough amount for a commercial application. So we are specifically focused on to the various photoelectrodes. We are designing various kind of heterostructures based on semiconductor materials as well as nitrides and their heterostructure to play with their band gap, so have to maximum charge separation and participation in the water splitting reaction. And not only to the electrode, we are not stick only to the electrode part. We are working with certain industries, certain companies to come up with a product for utilizing the generated hydrogen out of this particular kind of system. So we are in close collaboration with the two companies on utilization of hydrogen for rural sector as well as for the automation sector. Then third area which I feel that we can have some discussion or collaboration with SCO countries is under this because of this COVID environment, the things, the air, clean air has become of prime importance. So the air free from the viral load, from the microbes, and even from the pollution, SOx, NOx, and CO level, this is also very much important. So we are working again using our expertise of catalytic material development. So we develop various kind of catalytic platform which are highly effective towards various kind of degradation of various kind of pollutants as well as degradation of microbes. And we have come up with a very close design, and this is one industrial activity which we are doing. And in this we have developed two different models. One is a tabletop air purifier and another is an industrial air purifier. And this work we are again doing with certain companies, and two companies for industrial model as well as the tabletop model. What are the possible collaboration? As a material engineer, I specifically work on design of the material part. So just to, like I presented in brief, for hydrogen generation, for pollutant degradation, and water quality devices. And I look for collaboration with the young scientists from SCO nation, specifically in the area of novel functional materials, which we can design for various even emerging water pollutants like PP, CP, pharmaceutical and personal care products. And we can come up with some good products which could find a huge potential, huge application in SCO nations. Another thing is to have, I'm looking for some interdisciplinary collaboration for the citizen science involvement in the water quality monitoring with kind of the sensor platform developed, having a smart feature, IoT feature inbuilt in this kind of systems. And another area is to have the heterostructure development for electrocatalytic and photoelectrocatalytic hydrogen generation and exploration of potential of these hydrogen technologies. Right now, we are exploring it for the rural sector. So I look for collaboration where we can utilize this hydrogen generation technology for other vast sector, because the hydrogen is one of the promising technology. And last not the least, the kind of the materials, novel functional materials that could be designed for the treatment of the wastewater, because monitoring is not the one only thing. We also look for solution which can treat different kind of the wastewater coming out from whether it is from the cities or the industries. So there are different characteristics of the effluent which comes out from these different levels. So we are looking for the collaboration where we can come up with the novel unique material with high performance that could be translated into the products that could be deployed in different sectors, including industrial sector. So just to give a brief overview about my organization is an instrumentation organization which works on the basically products development, instrumentation development for various sectors, including agriculture, water, healthcare, and public safety, strategic sector. And we also are involved in training of the HR, manpower, human resources, to get them ready for industry ready products. And vision of our organization is to provide import substitution, to have self-reliance in the technology in these different sectors. And these are some of the recent technology, recent products developed by our organization, where head-up display is one of the key product from our organization, which is used in various aircraft. Then electrostatic pesticide spraying technology and electrostatic disinfection unit. Then earthquake monitoring system, which is deployed in different like in metros, and even it is being used in the wildlife application. And then for the medical sector, a portable reader for the blind people. So these are certain key products I have projected here, but we are working in a whole lot of domains where our major focus is towards the instrumentation solution. And we are a team of interdisciplinary people. We have expertise in different domains, including fundamental science to the and a computational engineer or mechanical engineer or a data scientist. So whole idea is to come up with the complete end-to-end solution for the targeted market and targeted application. And I look for collaboration with the young scientists in SEO. And if anybody wants to collaborate with me, they can reach me at these platforms. So these are different social media platform and web page link. So with this, I would like to thank everyone, and I would like to thank the organizers for giving me an opportunity. I'm open for the question. Thank you.
Thank you so much, Pooja. So if we have any questions, we can go with the flow of that. Okay, we have questions from the live audience.
Pooja, there is a question. Pooja, am I audible?
Yes, sir.
You know, have you developed this sensor for arsenic also? So what is the detection limit for arsenic in a water sample?
Sir, the chlorometric one is 1 ppm, and we are going to 10 ppb. That is what is required for WHO. The fluorescence platform is meeting the WHO guideline, which is 5 ppb. So we have platforms. We have two platforms. One is fluorescence, another is chlorometric. So fluorescence is able to do 5 ppb, and chlorometric is doing 1 ppm. And we are working on the chlorometric more, so that we can go down to 10 ppb.
Actually, we are facing a great problem of arsenic, particularly in also, and in in eastern parts of India.
Yes,
people are they are drinking the arsenic contaminated water. So
yes,
future for to commercialize this kit for arsenic detection in drinking water.
Yes, sir. That That is what we are planning. Currently 1 to 20 ppm it is able to give a in a one go you can detect whether arsenic is there or not, but we need to come down to WHO limit for the colorimetric platform. The fluorescence one we already transferred it to the industry, and they are getting their industry ready model ready for commercializing that model. But second model we are still working on to going further go down. 1 to 28 is very good.
Okay, thank you.
Audience.
Good afternoon, ma'am. May I know the limitations or drawbacks while designing the electrodes?
Okay, so the major challenge in designing the electrode is first the rate of production of hydrogen. Like when we talk to industry, they have certain benchmark that this much liter hydrogen per minute has to be there, because when we want to use it for any say automotive sector or some other application we are exploring. Second is the stability. The stability is very important criteria, that it should not corrode over time. What is the stability of the electrode? 100 hours or more than that. So industrial requirement is very high. So as a R&D person, as a material engineer, we have to address these major challenges. It should have high efficiency and stability.
Thank you, ma'am.
All right, Pooja, thank you so much. Well, here we're going to be moving to the next presentation. And now may I kindly request Satish Murli from CSIR Central Leather Research Institute, Regional Center of Extension Development, Kolkata, India, to please take over the forum.
Thank you, ma'am. Actually, due to the heavy cyclone and then the heavy rain, here the internet connectivity is very unstable. I request the organizer to take over this one.
So we have a video from his site.
Very good morning. Myself, Dr. Satish Murli from India. The topic of today's presentation is water-free natural fiber processing technique, strategies for development of solvent reagent model. Please go to the next slide. Click on it. Before going into the topic, I just wanted to brief you what is leather manufacturing and what are the major concerns. Basically, the collagenous layer of the skin matrix is only converted into final leather, and the leather processing is broadly divided into 4 segments, which is pre-tanning, where the non-leather making materials such as hair, epidermis and hypodermis are removed, and the tanning is to permanently stabilize the collagenous matrix against the bacterial degradation, and post-tanning to import or improve the functional properties such as softness and color and etc. And of course, finishing is to improve the aesthetic value of the material. The major concern of the conventional leather manufacturing systems are high water and chemical consumption. It is estimated that 40 to 50 liters of water is being consumed for the processing of every kilogram of raw hide skin. It is also estimated that the raw material to chemical consumption ratio is 1:1. Therefore, these 2 issues need to be critically addressed in order to make the leather manufacturing sustainable. Some attempts have been made to reduce the water consumption in leather manufacturing through various in-process control measures and recycling of the wastewater after treatment. In addition, scanty attempts have been made to completely replace the water with organic solvent, predominantly the halogenated hydrocarbons. Though the non-aqueous tanning system shows promising results in terms of zero discharge of wastewater and better processing efficiency, the toxicity, volatility and flammability of the solvent are the major drawback. Therefore, identification of the green solvent and its usage in leather making would balance the system. Next slide. In this regard, we have attempted to design a solvent selection tool for identification of green solvent for leather manufacturing. We all know that GlaxoSmithKline is one of the multinational pharma company where they consume huge quantity of solvent for the synthesis of drug molecule. In order to ensure the right selection of the solvent, GSK has developed a solvent selection guide where each properties of the solvent were rated on a scale of 1 to 10. Higher the point, better the solvent. Here we have taken GSK solvent selection guide as a basic database and developed a solvent selection tool for the identification of green solvent for leather manufacturing. Here I am not going into the detail of the solvent selection methodology. For further information, you can refer my paper that was published in Green Chemistry. Next slide, please. Based on the study, we found that carbonate solvent has a potential to replace the water in leather manufacturing. The use of carbonate solvent in tanning process and its environment and economic benefits are well established. It is also evident from the figure that the waste liquor discharged from the conventional water-based system is having the unused chemical, whereas in the case of carbonate-based solvent system is completely free from the unused chemical. Surprisingly, we have also observed that the leather processed with the cyclic carbonate system possesses inherent antimicrobial activity. It is also evident from the figure that the leather processed under propylene carbonate medium shows no fungal formation even after 60 days, whereas in other system, it shows fungal formation within 1 week. This is a turning point to us where we had a thought, why don't we use carbonate solvent as a reagent for leather making as a solvent cum reagent model. Next slide. Further, we have systematically studied the antimicrobial property of the carbonate solvent, and we have also used the solvent for the skin preservation as a replacement to salt. Further, we also use the carbonate solvent as an alkali neutralizer in leather manufacturing, because generally the alkaline treatment is necessary for the removal of hair from the skin matrix, and the subsequent removal of alkali is also mandatory in leather manufacturing. Conventionally, ammonium salt is being used for that purpose. However, the liberation of ammonia gas is the major drawback. Here, we have completely replaced the ammonium-based salt by using carbonate solvent, and also established the carbonate solvent-based neutralization process. Next slide. Like carbonate solvent, switchable solvent is also emerging in various fields of application. The hydrophobic and hydrophilic character of the solvent can be easily switched. Predominantly, carbon dioxide is being used for that purpose. The use of switchable solvent in oil extraction is well established. The similar technique can be used for removal of grease from the leather. Conventionally, surfactant is being used for the removal of grease from the skin matrix. However, the separation of the fat from the wastewater is difficult. Here, I would like to state the quote that things get measured, managed effectively. For any new development in manufacturing sector, especially leather making, that involves series of unit processes and consume variety of chemicals, it is important to quantify the environmental efficiency index of each process as a universal value. It helps to understand and predict the holistic view of the new development. Therefore, integration of green solvent based fiber processing, development of auxiliary from the used green solvent, and implementation of environmental efficiency model would really pave way for solvent cum reagent model as a holistic view. I would like to collaborate with SEO Nation in the following area, like synthesis of water soluble polymer and cross-linkage from the cyclic carbonate, and exploration of switchable solvent in leather making, and development of leather auxiliary from the switchable solvent. Central Leather Research Institute is one of the national laboratory under the Ministry of Science and Technology, Government of India. It is the world's largest R&D center in leather, founded on 24th April 1948, and we have more than 250 staff members, and we also have well sophisticated accredited instrumentation and testing facility, and the major activities, R&D activities on development of leather process technology, where we predominantly concentrate on water and chemical footprint reduction, and we also develop registered substances free leather chemicals, and we are strong in waste management technology for both the solid and liquid. And we do develop a collagen-based healthcare product, and we have a very good computational facility, polymer, biotechnology, and microbiological facility.
Next slide.
Thank you, Unadal. Thank you.
Thank you so much, sir. Well, moving on to the next presentation, we're going to directly make a move part in. That's by Mambejanova Nurila. He's a scientific advisor, Doctor of Chemical Sciences, Kyrgyz National University, to please take over the forum site.
Sure. Am I audible?
May I request you to kindly share your screen?
Сейчас.
Full screen. I request you to please make it as a full screen so that we'll be having a better visibility. Yeah, perfect, perfect. Yeah, you can go ahead.
Good afternoon, dear participants of conference. It's a great honor for me to speak at such a large international event. I represent the Kyrgyz National University, named after Yusuf Balasagun, Bishkek, Kyrgyz Republic. For your attention, I present a report on the topic obtaining humic premixes based on complex processing of natural materials. Scientific advisor, Doctor of Chemical Sciences, Professor Anar Zaripova. Today, such branches of agriculture as livestock, poultry, and fish farming is practically have become completely dependent on the high technologies necessary for improving, accelerating, increasing the growth, development, and productivity of livestock, birds, or fish. A particular role in the success of the breeding process and innovation feeding methods belongs to feed additives for animals and birds. Purpose of the work, first, release of humic substance from coal of the Karakiche deposit. Second, isolation of components from natural limestone shell rock. And third, physicochemical characteristics of limestone shell rock. Research object, development of methods for the synthesis of components for obtaining humic premixes on the basis of complex processing of natural materials. Here we see a sample of the obtaining humic acids and brown coal deposit Karakiche. On this slide is shown the shell limestone of the Saratash deposit, Osh region, Uzgen district, which is the object of our study. Saratash is a brownish yellow or yellowish white breed. It belongs to a decorative architecture expressive breeds. The surface of this material perfectly breathes due to its high porosity, is resistant to temperature extremes, and has low thermal conductivity. In the next slide, we are samples isolated complexes from limestone shell rock, and table 2, mineral composites of the study samples of travertine. We are participant of research project under the guidance of Professor Zaripova, research grant from KNU, Kyrgyz National University, named after Yusuf Balasagun, projects and humic nanoparticles, obtaining and studying properties. And second, project research grant from the Ministry of Education and Science of the Kyrgyz Republic. Project topic: obtaining humic premixes based on the complex processing of natural materials, and participant of scientific conferences. It was revealed that the use of certain approaches to chemical processing of oxidizing brown coal, limestone shell rock, makes possible to isolate components for their subsequent use as final components for obtaining humic premixes. And second, the determination of the mineral composition of the studied samples of travertine, limestone shell rock, was carried out, and a series of components have been prepared for the production of humic premixes: calcium, sodium, potassium, iron-containing carriers. Our scientific group conducts research in the field of obtaining and studying the properties of organomineral premixes based on the processing of natural materials of the Kyrgyz Republic. Our scientific group wants to find partners and wants to participate in international scientific projects. We propose to expand the range of international seminars, roundtables, conferences on the platform of the Shanghai Cooperation Organization. On the next slide, we wanted to give you information about the university and with the participants of the working group. Thanks for your attention. Have you questions? Вот сейчас получится.
By any chance, if we have any questions from the live audience, we can go with the flow.
But I must congratulate Nurila for nice presentation. Your work has very great potential for the industrial use. So I hope you will continue working, and particularly in collaboration with other SCO country. Thank you.
Thank you so
much.
Thank you very much. All right, so any other question do we have from the audience? Okay, I guess we are pretty much clear. Thank you so much, ma'am. It was really lovely to have you over here with a great presentation at the same time. And now I think it's the time to proceed with the next presentation. So now may I kindly request Mr. Oman A. Ebishev from Kyrgyz National University to please take over the forum.
Good day, dear colleagues. Do you hear me?
Yes, yes, we can.
Okay, fine. Okay. Do you see this slide screen? The title, yes?
Perfect.
Okay, thank you very much. Good day, dear colleagues. And I'm very glad to take a part of today's conclave. And I want to present a summary of our research project of the smart factory for biotech products in the Kyrgyz Republic. My name is Aman Abashev, and our scientific supervisors Anna Zaripova and Evgeny Yablachko. Oh, sorry. The premixes is the object of our research project, and the premixes are complex homogeneous mixtures intended for enrichment of compound feed, protein, vitamin, mineral additives, and feed mixtures. This complex contains biologically active substances, vitamins, trace elements, amino acids, medical and other drugs. On the right hand, the industrial cyber-physical systems are the state-of-the-art innovative field of research and development of new generation production system engineering. General, an ICPS is understood as a technical system network which consists of the next interacting subsystems, digital and physical components. On the right side of the slide, you can see the smart factory concept based on service-oriented and intellectual agent. Applicable for bioengineering and biotechnology as part of engineering sciences, the ICPS technology could provide a new way for multidisciplinary collaboration between the wide scope of engineers and specialists from chemistry, biology, production automation, data analysis, and many others. In particular, new ICPS design approach and the smart factory paradigm could become extremely efficient in biotechnology industries, taking into account in complexity, safety regulations, and dynamics. The industries will be able to create new personalized products for users based on the new information and operational technologies in accordance with the high dynamics of changing consumer requirements and market expectations. On the slide, you can see the smart factory technological framework, especially for biotech products. The research project overview and the research project objective to create a technological framework and an architecture model for biotechnological smart factory in order to support and encourage exponential growth of CSO member states, sustainability and prosperity. There are several key ideas which is the foundation of the project. First of all, apply the ICPS paradigm to transform traditional solutions and technologies for bioengineering industries, in particular in agro-industrial sector. Ensure high production process efficiency and respect for the unique natural environment of Kyrgyz Republic. Apply the proposed technical solution for organizing the production process of biotechnological synthesis of complex compounds. Multifunctional premixes based on humic substances isolated from the brown coal from Kizilkia and Karakiche from Kyrgyzstan. Create a flexible manufacturing enterprise that can produce customized products in wide range and batch size for the agro-industrial sector. Okay, on this slide, you can see innovation deliveries in the framework of this project. First of all, proposed smart factory models consist of 3 layers: service systems, data warehouse, and physical objects. This is the key ICPS organization and understanding. On the slide, you can see the physical entities have their digital representations, digital shades or twins. Each of the representations have their own workflow logic, databases, informational models, and interfaces. It allows to communicate in united digital ecosystem as intellectual model agents. It's equal for raw materials, products, production cells with equipment units, and robots. Additionally, there are cloud services for design, engineering, and management processes. Integration topology is the main aspect for established communication in decentralized, flexible, and reconfigurable production model. On this slide, you can see that our production cells, assets, and technological equipment is going to be connected via machine-to-machine communication net. Human and any machine or product which are connected to the united digital ecosystem through standardized M2M and HMI interfaces. The standardized semantic and syntax become important requirements. On this slide, you can see a proposed realization of digital architecture. There are a lot of intellectual agents connected to the cloud hub through gate interfaces. The core of the solution consists of a united data model which is stored in products, processes, and resources data warehouse. In agro-industry, it's important to have a way to create non-standard products which could face to special requirements formed by agri-tech engineers. It means that we need to be capable to produce special premixes for special purposes. For example, mineral-enriched cattle feeding premixes or medicine premixes. On this slide, you can see proposed premix composition designer. It's designed to develop and virtually test new premix composition and its processing technology. Based on computer-aided design and aided design and simulation software, this service would provide finite process workflow specification with optimized parameters, which is important for a smart factory establishing and organizing. Current project research cooperation is based on 2 major research partners. First, the Kyrgyz National University, named after J. Balsagin from Kyrgyz Republic, and the research domain is chemical technology, processing workflow, and material design. From these institutions, the research supervisor is Doctor of Chemical Science, Anar Ripova. And the second member is ITMO University from St. Petersburg, Russia, which research domain is process optimization, smart factory, and digital design. The research supervisor from this part of the team is Professor Evgeny Yablishnik. There are key members of our project team, and Kyrgyzstan Technology is an industrial partner, which provides additional support to form a test bed for our research work. Thank you for your attention, and if you have any questions, I'm ready to speak. Thank you very much.
Do we have any questions from the live audience?
Thank you, Dr. Oman. I think your work and Ms. Nurila work has some overlap. So do you locally collaborate with that team? And what is,
Thank you.
yeah.
Okay. Thank you for your question. Yes, you're right. We're collaborating. I am mostly participant from ITMO University because my research domain is mostly smart factory and automatization. The chemical technology and other biotechnological research foundation is mostly proposed by National University. Yes, and Nurilia is our colleague. Yes, you're right.
And from SCO country, do you have any plan for collaboration vis-a-vis your research work or any other areas in coming years?
Thank you. Yes, we have a plan to finish our prototype testing on the test bed, industrial test bed, and the next stage of the research project is to find an additional platforms and areas to implement these prototypes and also to improve the technology. Because it's, as I mentioned before, it's very important because smart factory as an industrial platform could be very useful not only for premises production, but only for other goods, which is based on biotechnologies. So yes.
Okay, thank you very much.
Thank you.
Thank you so much, sir. Well, here we'll be moving forward with the next presentation. And now I would like to request Dr. Muslimbek Pirnazorov to please take over the forum. He's from Turin Polytechnic University, Uzbekistan. We're going to be waiting for 30 seconds. If you're available, then please take over the forum. Dr. Muslimbek Pirnazarov. All right, so now I would like to request Elena from Institute of Biology of the Southern Seas, named after A.O. Kovalevsky, RAS Russia, to please take over the forum.
Do you see me?
No, ma'am, we can't.
Do you see me?
No, not really, not yet.
Do you see my presentation?
Ma'am, nothing is visible. All I can hear is your voice.
And do you see my
Yes,
presentation?
yes. We can. Just put it as a full screen.
Okay.
Yeah, perfect. And please switch on your camera so that we can see you as well.
And
your camera is off.
Okay, dear friends, What?
Ma'am, actually your camera is off. You can switch it on, then we can see you as well. And keep your presentation with full screen. Yeah, perfect. You can keep your presentation as a full screen.
It's okay?
Yeah, perfect. Please
now
go on.
It's okay?
Yes. Yeah.
Okay. Dear friends, I'm senior researcher in Institute of Biology of the Southern Seas in Russia, and it's a big pleasure for me to be with you and to make my presentation. Today, I want to tell you about saline lakes for nature conservation and sustainable development. The general tasks of my research is first, study of structure, functioning, and dynamics of saline aquatic ecosystems with salinity of more than 35 grams per liter. The aim is to understand the contribution of climate variability and anthropogenic influence on long-term ecosystem changes. And second, development of a scientific ecological base for sustainable strategy and technologies for the multipurpose use of saline lakes, including for aquaculture. The main territory of my research is Crimea, the largest peninsula on the Black Sea, with area more than 27,000 square kilometers. There is a large diversity of saline ponds, lakes, and lagoons with wide salinity range from 5 to 300 grams per liter, including the largest saline lagoon in the world, Sivash Bay. I also worked on saline lakes in Egypt, in China, India, and Iran. Here you can see some saline lakes in Crimea. This is lakes of marine origin and continental origin. Marine lakes separated from the sea by the sand spits. I conducted the field and experimental studies on many water bodies in different countries, as well as on different issues. I paid main attention to study biodiversity, food webs, relationship of biological and geochemical processes, ecosystem structure, functioning, and long-term dynamics of ecosystems, as well as biology of the different species which were easy to use in multi-species aquaculture. Now I'm head of some projects. This is state assignment project of our institute, study of the structure and dynamics of ecosystems of saline lakes and lagoons in the face of climate variability and anthropogenic load to develop the scientific basis of their relation use. The project of Russian Science Foundation, development of biological and geochemical basis of aquaculture development in hypersaline lakes and lagoons of the Crimea. And the project of Russian Foundation for Basic Research, study of diversity and the role of animals in food webs and element cycles in extreme ecosystems of the Crimean hypersaline waters. Here you can see my team. I work on the projects with my good team, including young and experienced researchers, and I'm grateful to all of our team members. And my innovative idea and approach with expected outcome. The growing human population faces many challenges. Loss of biodiversity and ecosystem disturbing, lack of fresh water and nutrition are the most important challenges for developing humanity. The study and sustainable use of saline lakes and lagoons are directly related to solving these problems. Aquaculture development can be one of the most promising ways to overcome the problem of food lack. But production in inland waters is higher than in the marine waters. inland aquaculture demonstrates the fast growth in fresh waters, contributing to their eutrophication, thus reducing the reserve for drinking waters. The increase of freshwater aquaculture prevents a successful response to other current problem, the increasing demand for fresh water. A way to overcome this is to develop aquaculture in the saline inland waters without compromising the supply of drinking water. To solve the problems of nature conservation, lack of fresh water and nutrition, sustainable development of integrated multi-trophic aquaculture in saline waters is needed. This is very important, first of all, for arid areas, which occupy a significant part of the territory of our countries, to reduce the human press on fresh waters. To go this way, we need to have a deep knowledge on the structure, functioning, and dynamics of ecosystems in saline waters, as well as on the promising for aquaculture species of aquatic organisms and their interactions. Several fish and shrimp species can be cultivated in saline waters, and some of them you can see here. On this slide, some species which can be successfully cultivated in saline lakes. This is a different microalgae, including Dunaliella and Chlorella. This is filamentous green macroalgae, including Cladophora and Ulva. Different species of crustaceans, Anostraca, Cleidocera, copepods, and some amphipods. Our team would be glad to initiate the joint project, study, conservation, and sustainable multipurpose use of saline lakes and lagoons for global, regional, and local sustainable development, including for aquaculture. And I think that the national team's leaders in such project may be young scientists, but of course more experienced colleagues must be very valuable partners. The results of such project must be not only pure science, but also integrated strategy and technologies for a sustainable use of saline water bodies, for a transit to sustainable development on different scales. Areas of our interest, it's environmental protection and natural resource management, and agriculture and food processing. And some words about our institute. Institute of Biology of the Southern Seas of the Russian Academy of Sciences is one of the oldest and most respected marine research centers in the world. Main sectors of research: aquatic ecology, systematics and taxonomy, living resources including fisheries, aquaculture, ecotoxicology, biotechnology, and physiology. And in next year, our institute will celebrate its 105th anniversary, and you are welcome. I'm glad to say thanks to organizers of this interesting web meeting, and thank you for your attention. Do you have some questions?
Any questions from the live audience? Yeah, we do have, ma'am. Just a second.
Good afternoon, ma'am. I have a question. Is there a relationship between
Okay.
aquatic vegetation spread with lake eutrophication?
You can be a bit more louder.
Is there a relationship between aquatic vegetation spread with lake
yes,
eutrophication?
of course.
Can you explain, like?
Can you repeat?
Is there a relation between aquatic vegetation spread with lake eutrophication?
Oh, I think no. In some cases, maybe.
Okay. Not in like saline lakes?
No.
Dr. Elena, there is a question from my side.
Okay.
Am I audible? If you for the food production from the saline lakes, if you compare with the hypersaline and saline lakes, and in the comparison of hypersaline and saline, which lake is, I think, more productive for aquatic food production?
Of course, many common species in saline and hypersaline lakes, but salinity a main factor.
Yes.
All right, so do we have any other questions? Okay, I think we are pretty much clear. So now, thank you all. Let's take a small break of 10 minutes, followed by Young Scientist presentation by Dr. Makisha Nicole. And I request all the chairs and young scientists to kindly join back for the session after the break. So it's going to be a 10 minutes break. All right, so yes, welcome back to all the presenters as well as our chairs. Well, we are moving next to the next presentation, Young Scientist presentation. And here I would like to request Makisha Nicole to please take over the forum. She's from Moscow State University of Civil Engineering, Russia.
So I hope good day, everybody. I hope my face is clear. And
so
my
we
voice
can't
is
hear
clear.
you up. Can you be a little bit more louder?
Yes, I try to speak louder. So
Yeah, perfect. And also, if you can put it as a full screen for a
yeah, of course.
visibility. Yeah.
So now it is full screen.
Yeah, perfect. Please go ahead.
Let me please welcome you once again here, and I'm very glad to be a part of this wonderful meeting. So my speech today will be about the reconstruction of wastewater treatment plants to conserve water resources. So I try to share a bit my experience and experience of my colleagues of my team. So I represent Moscow State University of Civil Engineering from Russia. When we speak about the reconstruction or modernization or upgrade of wastewater treatment plants, we should base on something. And one of the basement and one of the basics that we should rely on is our requirements of our regulation, and they are quite strict. And if we speak about the reconstruction of wastewater treatment plants, we should bear in mind that most of them were constructed at least 20 or 30 years ago. So they are faced with the wear, and they are faced that their initial values they were designed on, they are not correspond to current values. So the values were strengthened, and the values were extended. So we have to face to BOD suspended solids at about 3 and 5 milligrams per liter correspondingly, and also nutrients were added to this list, and these values are quite strict. So another issue we have to face and we have to deal with is if we want to meet the regulation and meet the requirements, we face the growth and significant growth of energy consumption. And if we take into account the wastewater treatment plants of the capacity of 100,000 cubic meters per day, so in case of conventional treatment, it will be 700 kilowatts, and in case of up-to-date modern technologies, it will be 2 or 3 times higher, mainly because of the nitrogen oxidation, because of the sludge treatment process, because of the UV disinfection, mechanical dewatering of sludge, and so on. So all these points gives us the extra energy consumption, and we have to adopt our technology to reduce these values to be in the limits, so to say, to be energy efficient as well. So the directions of our researchers, the directions of our implementations, and directions of our practical application is the energy efficient technology, energy efficient solutions, and the regulation of the facility, which are interrelated and interconnected. So next, some words about what was done by us, by our team, and what aims we had and what results we obtained. So the idea and our main goal was to invent solutions that may both achieve requirements of the quality. This technology should not produce a big amount of sludge, and the whole technology should be economically supported. So it should be effective and should be efficient. So this is the scheme of the technology. Of course, it may be modified according to the feed water concentrations, according to initial conditions, according to local conditions. But one of the examples is shown on the screen. One of the examples is shown on this slide. So as a result of the technology, we can highlight some important points that should be met, that should be achieved, such as quality of treated water. That should be, as on the first slide, it's the spatial limits of the wastewater treatment plants when we speak about the reconstruction or modernization. It's the reduction of the excessive sludge amount, and of course, it's further treatment, further application, for instance, like an energy source by creating a biogas, or by fertilizer, but that should also meet the requirements and the regulation, of course. Reduction of the energy cost is one of the key factors of the implementation of this or that technology. And of course, the stable treatment process, and that would not be forced and impacted by any outer actions, so to say. That was in brief what was done by us. And of course, that is a tiny piece of our field that we're working with and working at. And I would like to gladly invite our colleagues for collaboration, for our mutual success. And fields of our interest are civil engineering, environmental engineering, issues of urban infrastructure, green technology, sustainable development, energy efficiency, and renewable resources. And a few words about the university I'm presenting. So it's the Moscow State University of Civil Engineering, and we are trying to be worldwide involved. So we have a lot of partners, from over 100 partners from more than 30 countries. So some of them are shown on this slide. And we have quite an extended laboratory base that allows us performing various researches. And next year, our university will have an 100-year anniversary since it was founded. So thank you once again for your attention. I hope our further communication will be very successful. And please feel free to ask questions. That will be a pleasure for me to answer them.
We do have some live audience questions.
May I know the capacity of that treatment plant?
So the figures that was shown within my presentation were linked with the capacity of the treatment plant of 100,000 cubic meters per day. So it's about 400,000 or 500,000 of population if we speak about the urban wastewater.
Thank you, sir.
Any more questions? Professor Nc Gupta, you need to unmute yourself, sir. You're saying something, but we can't hear you up. Yeah.
Nicole, how much energy we can save in this new construction of wastewater plant? Is there any saving of energy on this reconstruction?
Well, it depends on most factors, but if we apply this technology according to our research and according to our results, we can save up to 50% of the energy. If we compare with the technology that will give us similar results of quality treatment. So we should, if we compare, we should always think about the alternatives that will give us the same results, because we cannot compare them to the technology that needs less energy, but they are totally inefficient from the technological point of view.
Thank you.
Thank you very much for your question.
Thank you so much. Well, any more questions, or are we done with the presentation and everything? Okay, Nicolas, I guess we are pretty much clear with the presentation. Thank you so much for being here with us.
Thank you very much.
All right, so ladies and gentlemen, we're going to be moving to the next presentation by the young scientist. And here I would like to invite Sitsev Semyon from Institute of Oil and Gas Problems of the Separation Branch SBRAS, Russia. And we are going to present his video over here.
Good afternoon, colleagues. My name is Semyon Sivtsev. I am from Russia, Republic of Sakha-Yakutia. I am a postgraduate student of the Institute of Oil and Gas Problems. I would like to present to you a work called Development of Innovative Biotechnological Products for the Purification of Oil-Contaminated Lands in the various natural and climatic conditions. As you know, pollution of the environment, oil spills, is an acute problem of our time of the world. Oil compounds are highly stable and difficult to degrade. The soil self-healing process is very long, from 20 to 50 years. It is possible to shorten the time of restoration of distribute lands by the biological method by increasing metabolic activity of the natural microflora of the soil. This can be done by changing the corresponding physiochemical conditions of the environment, introducing microbial biological products, or self-decomposing petroleum biosorbents into the soil. We have isolated hydrocarbon oxidizing microbial cultures from samples of oil-contaminated soils taken in the Republic of Sakha-Yakutia. It has been established that the main role in the degradation of oil in permafrost soils of Yakutia belongs to prokaryotes of various taxonomic groups of the kingdom bacteria. The main feature of the obtained microorganisms is the ability to maintain their vital activity in permafrost soil at negative temperatures. During thawing, the productivity of the mixed culture introduced with the biological product is gradually restored due to the multiplication of microorganisms that have retained their viability. The product of the project is petroleum biosorbent. A biosorbent is a dry form, a natural carrier of a sorbent immobilized by strains of degrading microbes. In the production process of biosorbent oil, secondary rough materials are used, which is economically profitable and positively affects the low cost of the product. Under the influence of microorganisms, the decomposition and utilization of oil products and the oil biosorbent itself take place, which absorbed oil products from the soil surface to environmentally friendly substance, which allows leaving the spent oil biosorbent in place of its use without further disposal. The resulting oil biosorbent will combine several functions at the same time, such as being used an oil sorbent, oil destructor, and fertilizer, what makes the oil sorbent economically and environmentally beneficial. Possible cooperation with the SO states, exchange of information and ideas, as well as we can test the effectiveness of our biological products in your country for research purposes. The Institute of Oil and Gas Problems is mainly concerned with the problems of geology, field development, transpiration and processing of hydrocarbon raw materials in the far north, as well as the problems of material science and technology for obtaining modified polymer, the composite materials. Thanks for attention. Good afternoon, colleagues. My name is Semyon Sivts.
All right, ladies and gentlemen, so with this, we're going to be moving to the next presentation. And to have a next part done, may I now request Samakulov Almir to please take over the forum from Kyrgyz National Agrarian University, Kyrgyzstan.
Hello, everybody. Am I audible?
Yes, you are.
Okay. So let me initially introduce myself. My name is Almir Samakulov. I'm from Kyrgyzstan. I'm a master's student in Kyrgyz National University. And let me introduce my work. And so it's a great honor for me to do a presentation here in this type of large event, scientific event, okay? So let's start our
Sorry for the interruption, sir. Sorry for the interruption. Actually, I logged in with 2 accounts, I guess. We are not able to hear you properly.
No, I have logged in with normal normal computer. Now I have better connection.
Okay. There's some echo.
Okay, let me turn off. Okay.
Okay, just give us a second. Okay, can you try speaking once?
Now, how about now?
Yeah, it's perfect now. Please go ahead.
Okay.
Yeah.
Okay, so let me continue here. So now the topic is and the name of the topic of our presentation is humic composites containing iron and neodymium oxides and hydroxide nanoparticles, and which will be related with synthesis and characteristics of these nanoparticles. Now, here it's my name, and my research supervisor is Doctor of Chemical Sciences, Professor Zaripova Anar. Now, let's move on here. The research objects are the composites based on humic acids containing nanoparticles of iron and neodymium oxides and hydroxides. Okay. Now, the purpose of the work is the synthesis of composites based on humic acids that contain nanoparticles of iron and neodymium hydroxides, with subsequent study of the effect of production conditions on the physical-chemical properties of products. Now, what type of methods were used for the obtaining of composites? These are the first one is we were obtaining the composites by the method of chemical co-precipitation in the presence of argon. Okay. Now, another one, the second method we were using is by the method of chemical co-precipitation when exposed to a magnetic field. Okay. Now, and the last one is here, the ball mill for nanocomposite production. So these methods were used. Let's move on here. The table 1 contains the physical and chemical characteristics of humic acids. Now, humic acids here, ash, moisture, elemental composition too. Okay. So, and another one, content of functional groups too, milligrams of equivalent per grams. Okay. Now, all of them here are given in percentages. So, and in figure 2, we see that TEM results in determining the particle size of iron hydroxide samples obtained by oxidation in the following mediums. First one is in the strong alkaline medium, okay, and in the second one, and it's slightly alkaline medium. Now, the amount of pH will be also very important in here when we are obtaining the composites, okay. So let's continue here. And the figure 1 shows the sec curve of humic acids isolated from brown coal. This is from Kazakh region, okay. And it's located in Kyrgyzstan. Now another one, let's move on to the next part. So here we see the same micrograph of neodymium hydroxides. On the previous page we saw with iron hydroxides, but now it's neodymium hydroxides, okay. So same micrograph is shown in here. And table 3 contains, this table contains the magnetic properties of composites based on humic acids containing nanoparticles of iron oxides and hydroxides and neodymium oxides and hydroxides too. Okay. So we have done the experiments in situ and also in ex situ too. Okay. So these are the magnetizations now amperes per meter. Okay. Now let's continue here. And what type of innovation ideas does our work contain? Okay, let's come to this part. So the problem of the rational use of natural objects, especially minerals such as peat, coal and brown coal, petroleum, is very relevant since it covers several areas. Now, among them, we can highlight the integrated use of these objects within the framework of known technologies and, of course, environmental protection through the creation and use of alternative or modified products that improve environmental safety, optimize the technology of production, and expand the range of applications too. So another innovation ideas are, we can say that the work was actually initially aimed in creating polymer solvents of organic nature, especially based on natural polymers. Humic acids acquires great relevance. Now the latter, depending on the technology of isolation, can be isolated either in pure form or mixed with other humic products, hematomilanic, fulvic acids, or humin. Okay, now it should be noted also that humic acids are the main components of oxidized brown coals from the Kazakh deposit, which is located in Kyrgyzstan. So the use of oxidized brown coals is due to the fact that As a result of external conditions, spontaneous oxidation occurs in the places of occurrence, and the coal reserves become unsuitable for technological and energy use. In this regard, the study of their properties in order to find ways of effective use for obtaining a wide range of materials is very important. Among them, a group of composite materials based on humic acids can be distinguished too now. With good, they can contain good selective properties for the effective binding of ecotoxicants of various chemical nature and radionuclides. Now, the aim of this work is to synthesize humic composite materials with the introduction of nanoparticles of transition and rare earth metals into the polymer structure of humic acids. Now, and to study the effect of the conditions for the production on the physical-chemical properties of products. Mostly a variation of the synthesis conditions. pH, we were changing the pH, we were changing also the temperature to concentrations of substances, as concentrations of reactants too, as iron concentration, salts of iron's concentration, and the gadolinium salts too, and neodymium salts too. And they were considered, and which leads to the information of mixed samples consisting of nanoparticles of oxides and hydroxides of iron and neodymium, characterized by a wide range of properties. So in conclusion, we can say that it was revealed that depending on the condition and mechanisms, nanocomposites can be obtained characterized by the enhancement of the magnetic properties of nanoparticles and their aggregates when exposed to a magnetic field. So it is shown that the use of nanoparticles of rare earth elements will make it possible to modify the structure of humic composites as a result of the appearance of new centers characterized by luminescent properties. And in particular, by varying the concentration of a rare earth ion in the composite material, it will be possible to change the number and intensity of the luminescent centers located in the bulk of the polymer stabilizer. So here are the project participants. Now me in the first picture, and the second part, my supervisor, Zaripova Anar, and her students too. And another co-workers here are also shown too for you. Now about the institute and country, and our universities, the Kyrgyz National University, named after Yusuf Balasagun, is a university of Kyrgyzstan located in the capital city. Our capital is Bishkek. It's a state higher educational institute of the Kyrgyz Republic, the oldest and the largest higher educational institution of the Republic too. So it was established on 25th of October 1925 as the Kyrgyz Institute of Education. Now about our country, Kyrgyzstan is a country located in Central Asia. It is bordered by Kazakhstan, Uzbekistan, Tajikistan, and China. Its capital and largest city is Bishkek. So now the total population of our country is 6.5 million. Okay. Now, and what about the possible collaboration and areas of interest? Let's talk. Let's continue with them too. We work on topics such as synthesis methods of nanoparticles with magnetic properties, humic acids and their properties, obtaining metal polymer nanocomposites, polymer nanosorbents, iron nanoparticles, neodymium nanoparticles too. Now, our scientific group conducts research in the field of obtaining and studying the properties of organomineral premixes based on the processing of natural materials of the Kyrgyz Republic. Additionally, our scientific group is open to find partners and searches for opportunities to participate in the international scientific projects. We propose to expand the range of international seminars, roundtables, conferences on the platform of the Shanghai Cooperation Organization too. Thank you for your attention. Okay, now that's it. That was the end of our lecture. Okay, our presentation.
All right, so let's see if we have any questions by the live audience. Do you have any questions?
Yes, feel free to ask, and I will try to. I'm ready for your answering, for you to answer.
Professor Nc Gupta, sir, you have any questions?
I think it's okay. We can move forward. It's a nice presentation overall.
Thank you. Thank you very much.
All right, thank you so much, sir. Well, here we will move on to the next presentation. And the next presentation is by Khalid Mahmood from Pakistan Environmental Protection Agency, Ministry of Climate Change, Quetta. If he's available, then we'll be waiting for 30 seconds for him. I would like to repeat the name. It's Khalid Mahmood from Pakistan Environmental Protection Agency, Ministry of Climate Change. Is he available? All right, so the next presentation, the presenter, we have is Amjad Masood from Water Resources and Glaciology Section, Global Change Impact Studies Center, Ministry of Climate Change, Islamabad.
Yes, I am available.
Yeah, all right, sir. So it's your presentation. Please go ahead.
Yeah. So can you hear me? Hello, good afternoon.
Yeah, you can share your full screen, sir.
Yes.
Yeah, presentation full screen.
Okay. So good afternoon, everybody. Good afternoon.
Can we have it as a full screen, please?
Yes, yes, one.
Yeah, just to have a clear visibility.
Yeah, is it fine now?
Yeah, perfect, sir. Please go ahead.
Okay. So, oh, I'm sorry. Good afternoon, everybody. So my name is Amjad Masood, and I'm working in Water Resources section of Global Change Impact Studies Center. It is one of the pioneer center of Ministry of Climate Change, Government of Pakistan. So it is very honor for me to talk in this prestigious forum regarding an important issue of water resources and climate change. So I will talk about in this presentation about mainly water resources, global, what is the regional setting of our freshwater resources of Pakistan, and what are the challenges of these water resources, and then what are the key findings of our main impact studies. And then I will talk about the government of Pakistan's initiative in this regard, and then way forward. So you can see that this is the main South Asian picture, and this is Pakistan. And you can see this whole is called, this belt is called Himalayan belt, which just starts from Afghanistan through Pakistan, Nepal, India, and up to Bhutan and up to Myanmar. So it is very important as far as Pakistan is concerned, because three big mountain systems join together in our upper mountainous areas, which are Western Himalayas, Karakoram, and Hindu Kush. So this portion is also very important because 70 to 80% water resources of our river flows originates from this upper area, and this area is called Upper Indus Basin. As you know that this whole is Indus Basin, and it is main component of Upper Indus Basin of Pakistan. So this is the climate and weather system of Pakistan. There are two systems. One comes from Mediterranean Sea, and it comes into Pakistan through Iran, which is called westerly, and it mainly precipitates. It gives precipitation in mostly in winter season, while the other system comes from Bay of Bengal, which is comes from through India. It enters into Pakistan from July, August, and September. Also, some local precipitation also comes from Arabian Sea in this downstream areas. So this below is main Indus River system of Pakistan. I will talk about in next slide. So you can see that these are some main characteristics of water resources of Pakistan. This right side is a schematic diagram of Indus Basin network. This is main Indus River. You see, this is dotted line is the border line between India and Pakistan. Our main 5 rivers, Indus, Jhelum, Chenab, Ravi, and Sutlej, comes from India, and it goes through center of Pakistan, and it joins Arabian Sea. And mostly total water supply of this system is 193 million acre feet, which is the sum of river flows 143 and groundwater is 50. So average withdrawal of through canals is 101, and some losses are 15%, and escapage below Kotri is 26%. This Kotri is the extreme downstream station of river flows, measuring river flows. And we have main 3 main dams, Tarbela, Warsik on Indus, and one Mangla on Jhelum River. And similarly, 7 barrages, mainly most of them are on Indus Basin, and a couple of on other rivers. So these are major challenges to our water resources in context of climate change. You see, we have mountains, we have plains, we have downstream delta area. So in delta area and plains, we have problems of groundwater depletion, drought, seawater intrusion, while in upstream side, we have glacier retreat and glacier surge problem, which are major sources of flash floods, debris flow, glacial lake outburst flow, and landsliding. So based upon these challenges, German Watch report concluded and found that Pakistan is 5th most climate affected country in the world. You can see that these are an analysis of last 30 to 35 years climate events of how much climate events happened in the last 20 years, the 15 to 20 years, that you can see this box shows a lot of events, while before 2000, there are very less. So some key findings are in the coming slides regarding impact assessment of climate change in this area. So you can see this is one of the slide from our study, which is an hypothetical scenario we have generated from mean monthly flows for the period of record from 1995 to 2004. In this, we have assumed that the temperature rises 3 degrees C, while glacier area is reducing by 50%, then what will happen to our main flows? You can see that this purple color shows base flows in this graph, and this yellow color shows climate change scenario runoff. When in this temperature and glacier reduction, you can see that climate change scenario runoff comes earlier. It peaks in this yellow. You can see that it was in base runoff, it was in July, while in climate change scenario, it comes 1 month earlier. And similarly, the base glacier melt also flattens, and it is come earlier. It means that the river flows are first, glaciers are retreating, and it comes more water in early months, while in the last months in summer season we have very less water and it retreats, very river flows are reducing. So this flow is very important for the agriculture and crops and all these things. For is whenever we must have more water in that season. So this is another study in which you can see some annual and seasonal snow cover distribution for the transboundary Kabul River Basin over the period from 2001 to 2016. You can see here that this is Kabul River Basin, which is which is part of upper Indus Basin, and it is shared basin between Pakistan and Afghanistan. You can see these are some trends of snow-covered area in this whole basin. This shows the winter trend of snow cover, and this is the summer season snow, and it changes from 10,000 to 50,000 square kilometer. And this last one is the glaciers trend in this region. So this is very important. In the next slide, I will show you that what is the difference between the glacier-rich basin and snow-rich basin. You see, this is a snow-rich basin, which is Kabul. I show you in the previous slide snow-covered area, and this is attached, just adjacent basin, which is on the right side of this basin. Is in the previous slide you have seen that when there is glacier-rich basin, when we run this model, and we have received many in the future scenarios, you can see there this dotted line shows the baseline flows, while these other colored picture lines are showing future scenarios. And you can see that in both these scenarios there are more flows in future, and but they have only increase in flows, while in snow-rich basin you can see that as compared to base flows and the climate change scenarios, flows are coming early and sharp peak. So this is very important that and due to this early and sharp peaks, there are major floods in the future. You can see in this there are many dotted dots in the future scenarios, and which are very important as far as both Pakistan and Afghanistan basins are concerned. So this is slide shows the Pakistan government's response in the wake of climate change and these issues. In 2017, Prime Minister of Pakistan announced the climate agenda. The main points are safety and well-being of people. As you know, as we all know that lives of people are important for all of us. So how can we make our people's life better, and we can save people from these all effects, from floods, droughts, and all these hazards. So this is the first main agenda. And when people are safe, then there will be sustainable economic growth, and then we have to fulfill the international commitments like we are signatory of the climate change agreement of Paris Agreement, and similarly other climate change mitigations, and we are doing as much as we can. In this scenario, we have climate change policy, which was accomplished in 2012. We have Climate Change Implementation Action Plan. We have Climate Change Act 2017. And similarly, under these implementation actions, we are carrying out some projects like Glacial Lake Outburst Flood 1 we have accomplished. Now we are doing Glacial Lake Outburst Flood 2. And similarly, billion tree tsunami in one of the province of Pakistan, which is called Khyber Pakhtunkhwa. And similarly, we are carrying out 10 billion tree tsunami drive, clean and green Pakistan. We have a Prime Minister Committee on Climate Change. We are going to just start Recharge Pakistan, under which the main floods water will be diverting into barren lands. And these then barren lands will be the wetlands and which will be consequently good for the ecosystem of that area. Similarly, Pakistan has taken SDGs, Sustainable Development Goals, as its national development agenda. So these are some recommendations way forward, that more research is required to monitor the glaciers of our HKH region of Pakistan, especially in Karakoram's glacier, where most of the glaciers are concentrated. And for this research, we need to apply state-of-the-art remote sensing GIS tools, techniques to assess present and status of Karakoram glaciers using high-resolution satellite data. Similarly, field measurements on selected glaciers for validation are necessary, and develop appropriate adaptation measures to counter the negative impacts of climate change. And obviously, regional collaboration and managing the water resources under changing climate is very much necessary. We have, in this regard, one thing I am happy to mention, that we have a treaty between India and Pakistan, Indo-Basin Treaty, which is called. Similarly, we need to have similar treaty between Afghanistan and Pakistan, so that we should be on one page. And similarly, we have to build our political support involving private sector, gender integration into various efforts to address climate change. And we have to produce climate thinkers. We have to make awareness in schools, colleges, and all forums that this is very much necessary for all of us, for the safety of all of us. So thank you very much.
Thank you so much, sir. Professor Nc Gupta, sir, you have any questions?
Yes. Dr. Masood, very good presentation. I think you gave overall water balance, particularly from the from the glaciology point of view. My question is, if as you say, plus 3 degree increase in temperature due to climate change, if it happens, then because Karakoram glaciers are very important for Pakistan.
Exactly, yes.
So, do you think with plus 3 degree Celsius temperature rise, many rivers, I think in Pakistan, some few rivers, I think they may not be perennial in future.
Yeah.
So, the flow, glacier melt flow will be drastically reduced.
Yes.
What do you think? Is the country is prepared for that?
Actually, I have mentioned in that slide that it is a hypothetical scenario. We are already in 1 degree C increase we are facing all over the world. Everyone is facing, yes.
Right.
So we need to do research, and we need to be prepared to adopt such situation. This is one of the worst scenario actually. We have assumed that if such things happen, how we will be prepared. So this is just one of the study we have presented to our high-ups, that if such worst scenario will happen, this much losses we will be facing. So we have to be prepared in such difficult scenarios.
Because you may face the flash floods also in future.
Yeah.
Kind of scenario comes, because you are talking about the beyond Paris Agreement. Because if you are going beyond 2 degrees.
Yeah.
I think we should be prepared for that. Thank you very much. Nice presentation.
Thank you very much. Thank you very much.
All right, so we have one more question from the live audience. Can we have the question, please? Dr. Amjad, I would like to request you to please wait for a while. We have one more question.
Okay.
Hello. Good evening, sir. I have a question on impact assessment. What are all the parameters have you considered for doing impact assessment, and have you used any tool to do the assessment?
Yeah. So yes, we are a research-based organization. We are working in climate change. We are a research wing of actually Ministry of Climate Change, Government of Pakistan, and we do mostly modeling studies. And as far as our center is concerned, mostly we have 3 main sections. One is climatology. One is climatology and environment. So we use global circulation models and regional circulation models in that section. And the second one is water resources and glaciology section, in which we use different water hydrological models. Similarly, we have one other section which is agriculture section, which looks after the impacts of climate change on agriculture, and they are also using different agriculture models for that.
Like what about
and in this regard, we consider all parameters. For example, precipitation, temperature, humidity, every part of climate, and similarly the land use, land cover, all parameters from land and from atmosphere, and whatever are needed for these models.
Thank you, sir.
All right, thank you so much, sir. Well, I think it's time to move on to the next presentation. Thank you so much for your presence. So now I would like to request Sabahat Noor from National Agriculture Research Center, Ministry of National Food Security and Research, to please take over the forum. We're going to be waiting for 30 seconds. Sabahat Noor from National Agriculture Research Center, Ministry of National Food Security and Research. Are you there, sir? All right, so we're going to be skipping out this presentation and moving on to next. May I now request Dr. Saqib Jabbar from Food Science Research Institute, SRI, National Agriculture Research Center, Islamabad, to take over the forum. Dr. Saqib Jabbar. All right, moving on to the next presentation. Can we have Mr. Abdul Latif from PARC to please kindly join for the session? All right, so I guess it's time to move on to the next presentation, but we have a video of this particular young scientist, and the name is Wenbin Zhu, Associate Professor, Institute of Geographic Sciences and Natural Resources Research, Chinese Academy of Sciences. Can we have his video onto the forum, please?
Good afternoon, everyone. I'm Wenbin Zhu from Institute of Geographic Sciences and Natural Resources Research, Chinese Academy of Sciences. I'm very glad to have this chance to introduce our research as well as our institute and group. The title of my today's presentation is Allocation of Water Resources over the Amandaya River Basin for Sustainable Development, which is in fact a Uzbek and Chinese scientific and technical project. Firstly, let's look at the research background. Nc, located in the Central Asia, was once the fourth largest lake over the world, with an area of 68,000 square kilometers in 1915s. However, as a result of agricultural development as well as other reasons, as we can see in the map, Nc was divided into two parts in 1987, which were named after the South Sea and the North Sea. In 2003, the South Sea was further divided into the East Sea and the West Sea. Then, in 2014, the East Sea perished. It is obvious that Nc has been diminishing. The main reason leading to its shrinkage is the loss of river discharge into the lake. There are two big rivers flowing into Lake Nc, Amandaya in the south and Sirdaya in the north. In this research, we only focus on Amandaya River. Confronted with the shrinkage of Nc, the countries across this basin have also taken some measures. For example, Interstate Committee for Water Coordination has been formed after the disintegration of Soviet Union to allocate water resources over the Central Asia. However, the conflict is still severe, especially the competition of water use for power generation in the upstream and the water use for irrigation in the downstream is particularly fierce. Therefore, more needs to be done to manage water resources over the Amandaya River Basin. As you know, China has many big rivers and has accumulated a lot of unique experiences in the management of these big rivers, including transboundary rivers and inland rivers, which is just the case of Amandaya River Basin. Under this background, the Uzbek and Chinese scientific team have reached an agreement about collaboration in the use of Chinese experience to manage water resources over the Nc. Especially, the cooperation will include the following activities. The first one is technical and technological clarification of principles of water allocation and its control. The second one is institutional and legal aspects of management, including revision and reassessment of existing documentation, agreements, and order. The last one is the establishment of a system of models specific for the Amandaya River Basin, oriented to searching best decisions to meet the needs of hydropower, irrigation, water supply, and the environment, taking into account the need to guarantee water, food, energy, and environmental security in the region and each state. There are 4 cooperation objectives. The first one is modeling the flow of Amandaya River and its tributaries. Special attention will be paid to the impact of climate change. The second one is the estimation of the required water intake for various consumers. The third one is the study of the components of the channel balance and the development of a dynamic model. It's particularly important to characterize generation of return water, including both quantity and quality, its reuse, discharge into rivers. Contributions of these types of water to water consumption and water withdrawal need to be estimated. The last one is the development of water management rules for the Amandaya River and its main tributaries. The expected outcome of this objective includes new product, new database, and new software. In general, the major innovation of this project include the following 3 aspects. The first one is the method for more precise definition of river flow, taking into account travel time, return flow, losses, and glacier contribution. The second one is the elaboration of an optimal plan for operation of the river water system, taking into account water content, more precise estimation of water requirements, and decrease in idle discharge by hydroelectric power station. The last one is development of a system for sustainable water supply and strict adherence to water allocation plan, taking into account the needs of NRC. That's all about this research. Now I would like to introduce our institute and group. IGSNR is a multidisciplinary research institute focusing on, among other things, physical geography and global change, human geography and regional development, natural resources and the environment, geographical information systems and surface simulation, the territorial water cycle and the water resources, ecosystem network observation and modeling, and the Chinese agriculture policy. Through research in these domains, the institute aims to solve major natural resources and environmental problems related to national sustainable development and improve its urban innovative. Our institute is the home of 4 laboratories. I belong to key laboratory of water cycle and related land surface processes. This is the official website of our institute. There are a core of 6 staff in our research group, including 1 professor, 3 associate professors, and 2 assistant professors. Professor Solvent is the PI of our research group. This guy is me. Our research interest can be summarized as follows: water resource management for sustainable development, impact of climate change and human activities on water resources, remote sensing of evapotranspiration, soil moisture and drought, and water security evaluation for agricultural production. Based on our research interest, possible collaborations with SCO countries is studies on water resource management and its application in ecology and agriculture, especially those performed using remote sensing technique and hydrological models. Anyone who is interested with my research can contact me by ResearchGate and email. That's all. Thank you.
Thank you so much. Thank you to all the young scientists for their nice informative presentations. Now let's take a small break of 10 minutes, and that is going to be followed by thematic networking and group discussion on future perception to be moderated by Ms. Anchal Garg. And I request all the chairs and young scientists to kindly join us back after the break. Till then, thank you so much.